Welcome back to the Stronger by Science podcast. In today's episode, I formally announced that I am in fact a completely different person than Eric Helms, and Greg shares some impressive feats of strength. After that, I've got a research review segment about how antioxidants relate to nitric oxide and hypertrophy, and Greg tells us all about his new Stronger by Science article about the concept of effective reps. Finally, we interview Lauren Colenso-Semple, who tells us about her research on muscle fiber types, her recent study on training volume for resistance-trained females, and much more. As always, thank you for listening, and we hope you enjoy. Welcome back to the Stronger by Science podcast. This is your one and only host, Eric Trexler, and today I'm joined by my temporary guest host, Greg Nuckols. Before we get into the real meat of the episode today, I do want to come clean about something. So there's kind of an ongoing, I don't know how I'd put it. There's
I would call it an assault.
I was going to go toward there's some ambiguity out there that I feel like maybe I've been partially contributing to.
Well, I mean, just given the utterly depraved nature of the accusation here, I mean, I would call it a pretty major assault, personally.
Let's just get straight to it here. So today we're recording on a Thursday, which means an episode went live this morning, and like 2 of the first 4 comments were to congratulate Eric Helms on a job well done. And so I want to clear the air, and I want to put the rumor to bed. Eric Trexler, who is I, and Eric Helms, those are 2 completely separate human beings. So if you thought Eric Trexler was a pseudonym or like an alter ego that Eric Helms developed, that's not accurate. Eric Trexler is not some kind of shell corporate entity that Eric Helms created for liability purposes.
It's not like a Marshall Mathers, Slim Shady type relationship.
No, these are 2 human beings, just normal human beings, more or less, that are separate. So different families, different genes, different heights. We happen to live on separate continents. And so it seems like every episode there's a non-negligible amount of people who think that after about 40 hours worth of podcasting here, they still think Eric Helms is the host of the show. So I've considered a few possibilities. One would be that this is an elaborate troll operation, in which case I lost. If you were trolling, and that's the point of this, you win. I have been trolled hard. But
I think this is probably a Russia-funded operation.
Yes.
in connection with Guccifer 2.0.
Probably. So it could be a troll operation, in which case it is an extremely dedicated troll operation, because it's been going on for about 17 weeks, which is... That's a hell of a job.
It's like Gamergate all over again.
It is. Now, the other option is, well, one of the other possibilities is that this is a conspiracy theory, that Eric Trexler and Eric Helms are actually, in fact, the same person. Now, there are pictures of both of us in the same room at the same time. And we also did release an episode that was like 90 minutes of the 3 of us talking. And there were definitely 3 distinct voices. You can run that through some kind of software to identify. There were 3 separate human voices on that recording. But I will say this. Most of the pictures of me with Eric Helms they were taken in Finland, and a lot of people don't believe Finland exists.
And one thing to note, just for the conspiracy theorists out there, much like the Beatles conspiracy that Paul McCartney is dead, if you take the intro music to our podcast, press it onto vinyl, which is the only correct way to listen to the podcast, on vinyl, of course. Press it onto vinyl and play it backwards. The intro music does actually say Eric Helms is dead. So I that was completely unintentional. Our sound engineer, I think, just put that in to play a joke on us. But I can understand if that is where the conspiracy came from.
Yeah. So the thing that kills me is we've got like a good 90-minute interview with Helms on our show. I did like a good 90 minutes on their podcast. Helms and I are both listed as reviewers on Mass every month. So it should be pretty clear, like whether you consume his stuff or my stuff or both of our stuff, that we are in fact two separate entities. You would think, right?
I would hope so.
Okay, now there is a third option that this is a deliberate misinformation campaign by Omar and Helms.
Again, in conjunction with the Russians.
In conjunction with the Russians or the Dutch or both. So maybe they're behind this. I don't know. Then the fourth option is that I'm simply too low key and I need to talk myself up more on the podcast. And I guess probably in the third person. I think that'd be the only way to really get the name recognition across, wouldn't you say?
Sure.
So that's the only real actionable possibility. When you look at them, the rest are kind of out of our hands. So expect over the next several years a whole lot more of me talking about me in a very favorable way. Okay, so for today's episode, we got a lot going on. We do have an interview with Lauren Colenso-Semple. And we recorded this interview, when did we record that?
2 or 3 months ago.
2 or 3 months ago at minimum. Things have changed a lot in the last few months at Stronger by Science. In the last few months, we've made some big changes to our coaching program, which we don't talk about much on the show. But the first thing we did a while back was we added Greg Schiltz. And he's our registered dietitian on staff. He's also a close personal friend of ours.
And just to be clear, me and Greg Schiltz are also two different people. To keep up with this general audio universe, you do need to keep 2 Erics separate and 2 Gregs separate. But that should be pretty doable.
Yeah, so completely separate Greg Schiltz, who is our registered dietitian. And we brought him on, and then essentially all of our coaching positions filled up immediately. And so we just completely filled up everyone's rosters, and we figured, okay, it's probably time to grow again. And so in the last few weeks, we added 3 new coaches. So we added Jason Urey, who is a doctor of physical therapy, which is cool because that's a skill set we did not previously have on the team. We added Dale Keith. He was the lead research assistant in my dissertation research and the lead research assistant in Greg's thesis research. So we both know him extremely well and have been very much in the trenches with Dale. So he's a very good guy, very good coach. He's been training people for a while. Mm-hmm. And then finally, the reason I bring all this up, our interview today is with the other coach we recently brought on, and that is Lauren Colenso-Semple. Now, Lauren's, if you look at the coaching tree, to borrow a metaphor that she comes from, the lineage of people she studied under, it's insane. So she started out interning and kind of volunteering in Brad Schoenfeld's lab. Then she did her master's in Bill Campbell's lab at USF. And then she went and did an internship with Andy Galpin. And while she was doing that internship with Galpin, she spent a weekend at the Glute Lab over with Brett Contreras to, hang out and learn some stuff. Now she's doing her PhD under Stu Phillips. If you were into hypertrophy and sport nutrition, I don't know if you could select a better group of people to learn under. If you listed the top 8, there's no way that all 5 of them don't show up in there.
Yeah.
So she knows her stuff. Just the fact that you would bother to go learn from those people kind of tells you everything you need to know. This person at least knows where to get stuff, knows where to find information. So we interviewed her long before we ever intended to bring her on as a coach, honestly, because we wanted to hear about her study on training volume in female resistance-trained lifters. So if you stay tuned, you're going to hear that interview at the end of the show. But before we get to that, as always, we got to talk about Feats of Strength.
Yes, sir. So, Boss of Bosses 6 was pretty recent. That's I believe it's an invitation-only meet where a lot of the best lifters go compete every year. It's basically the World Championships for untested lifting. I mean, the IPL Worlds is also pretty big, but I would say Boss of Bosses, if anything, is a bigger meet at this point than IPL Worlds is. Not in terms of total number of lifters, but in terms of the number of records that are set. And so there were several absolutely insane performances out of that meet. One thing that is probably worth touching on is there were quite a few complaints about judging at that meet. Several squats on video at least looked high, and to this point, I haven't seen any side videos. So I didn't see anything as egregious as some of like the circa 2013 multiply world record squats, but there were definitely some that, to my eye, from the front angles that were available, did look highly questionable. But I mean, the judges called him good. I haven't seen a side angle. That's as far as I'm going to go as far as like that controversy goes. But the judging did seem somewhat iffy. But that being said, Yuri Belkin, who is the god of the middleweight untested men at this point, he competed at 220, or in the 100 kilo class. He has done several of his recent meets in the 242 or 110 kilo class, and that's mostly because he does the thing that Russian lifters do, where they just don't cut in a very easy amount of weight to cut. So this is something that like Belayev did back in the day as well, when he was taking 220 records that very easily could have been 198 records. But at his last few meets, like Yuri Belkin's been weighing in anywhere between like 224 and 228, but competing at 242 instead of cutting those like 4 to 8 pounds. But he did cut to 220 for this meet, squatted 416 kilos, which is 917 pounds, and totaled 1066 kilos, which is 2,350 pounds. Both of those all-time world records in the class. That put him, I can't remember if he was in first place or second place for all-time Wilks for male lifters. But if he wasn't in first before, he is now. That was a 649 Wilks, which is just absolutely stupid. So he also holds the record at 110 or 242. And the record he just set at 220 is higher than his 242 record, which he just set back in April, which again was set at a body weight of like 228. But he shows no signs of slowing down. He is the god of those weight classes. The next closest person at 220 is also a very, very good lifter, Tom Martin. But his best total is 1085, or in pounds, 2171. So there's like an 180 pound gap between Yuri and the rest of the class at this point. He was one of the ones where the squat was kind of iffy, but whatever. Like the lifts counted, huge record for him. Also from that same meet, I'm pretty sure, Christy Hawkins now holds all 4 all-time world records in her weight class. She competes untested in the 75 kilo class or 165 pound class. In kilos, she went 285, 150, 255 for a total of 690, or in pounds, that's 628, 331, 562 for a 1521 total, which, I mean, regardless of like knee wraps or drug testing or anything else, like those are sick numbers at 165 for anyone. And for a 165 pound female, that's also insane. Very similar to Yuri Belkin. She's miles ahead of anyone in her class right now. That puts her 140 pounds ahead of the number 2 total in her weight class. And like I said, that's the all-time records for 4 lifts simultaneously. I don't know if anyone has simultaneously held all 4 records in one weight class since maybe Lamar Gant. I think Ed Cohn may have at 198, but I'm not sure. I don't think he ever held the bench record. So that's an incredibly impressive feat. At the same meet, CC Ingram, who is kind of the boss at 181 or the 82.5 kilo class for untested women, she improved her all-time world record total to the surprise of no one because she's a beast. She totaled 737.5 or 1626 at 181, which again is crazy. On the tested side of things, Amanda Lawrence recently posted a PR deadlift gym lift. So USAPL Nationals are coming up. Amanda Lawrence, I believe, currently has the world record in that weight class, which is the 84 kilo class or 185 pound class. I believe she currently has the world record at 252.5 kilos or 557 pounds. So that gives her a gym lift that's about 20 pounds over her current world record. Looked like she still had some in the tank. And probably the most important thing is in the video she posted, grip looked very comfortable. She held it for several seconds at lockout. In the past, I believe she has been good for heavier deadlifts, but has pretty consistently had grip issues. So it seems like she's sorted that out and is probably going to improve on her own world record deadlift. And the 84 kilo class for the women is going to be a really, really fun class to watch at nationals this year, because Amanda Lawrence and Daniela Mello are both in that weight class. They're both young. I think Amanda's 22 and Daniela's like 20. They're still both improving very rapidly, and they're currently tied for the world record total in that weight class. And Amanda edges Daniela out slightly because at the meet where they both set the world record, Amanda weighed in slightly lighter. But they're like super, super neck and neck. Daniela hasn't been posting to Instagram as much recently, but I'm sure she's stronger as well. And that's going to be a dogfight at nationals that I'm very excited to watch. And then the final one for the day, actually, no, two more. So new all-time world record in the 67.5 kilo or 148 pound class for untested men, Mikey Estrella. Totaled 738 kilos or 1,627 pounds, which at 148, that's nasty. So that puts him, I think that puts him close to 25 kilos ahead of the second place total in that weight class. And one thing to note as well is Mikey Estrella, until very recently competed tested. He totaled like 1,420 pounds or so, tested at 148, and now he's put close to 200 pounds on that since he's gone untested just in the past like year or so. So he pretty quickly took the untested total record. So it's going to be exciting to see if he just, absolutely buries the rest of that class in the next year, or if he can even stay in the 148 class. But anyway, very, very impressive lift for him. And then the last one, and I think this was probably the most controversial recent lift, Julius Maddox, as we predicted on this very podcast, took the all-time super heavyweight bench press record, previously held by Kirill Sarachev at 335 kilos or 738 pounds. Julius Maddox chipped him, beat him by half a kilo, benched 335.5 or 739.7 pounds. The reason why this lift was controversial is the video that's been circulating around has kind of become like the Zapruder tape for powerlifting. This Zapruder tape is like the only good video of the JFK assassination, and like people try to piece together what happened from like this one grainy, not all that great video. It's similar with the video of this world record, because basically what happened is he pressed the weight. The press didn't look that hard, but I think that's just how Julius Maddox benches. Like it either looks pretty quick or just doesn't go up. But it looked like he got the lift cleanly, and then he just like dropped the bar on himself. But he did get the rack command from the ref, and so like as soon as you get the rack command, it's good. Like that's the end of the lift, whether or not the bar gets racked.
Yeah, it's just such an ugly video. Anytime something like that happens, you're just like, it's like a train wreck.
Yeah.
You know what I mean? When you see the bar getting dropped like that, you're like, oh man.
Yeah. And so the reason this has become like the Zapruder tape is it looks like when he locks it out, so he has a 5 spot. There's a back spotter and there's 2 side spotters. And what looks like happens is as soon as he locks it out, one of the side spotters throws one of his arms up like to start celebrating, and it looks like his other arm bumps the weight. And so that would like bump one end up. The other end of the bar did like dip at that moment, and that's when it started going down. but you can't tell for sure from the video if the guy's arm did actually hit the weight. And so, like, if it did, if you're holding 740 pounds over your face and someone nudges it, that seems like a perfectly reasonable reason for it to kind of collapse. So, like, if that happened, I feel like that cleans up a lot of the controversy. Like, the video still doesn't look any prettier, but, like, at that point, it's not on Julius. But if the guy didn't touch it, and it was that he, locked it out, but then just couldn't support it until, like, the fraction of a second before he got the rack command, then it is a lot iffier. But I mean, he was benching barely over 7 like a year ago. So I feel like he's going to improve on this record again. The next time he breaks it, he's probably going to do it more cleanly. But yeah, so that was the most controversial recent lift. But I mean, it passed. It's on the record books. Julius Maddox is the new king of the bench press.
Yeah, and he, like you said, it went up quick.
Mm-hmm.
It seems very unlikely that he would just absolutely manhandle that weight and then at the very top be like, nope, too much.
Yeah.
So I mean, and like you said, I think he's going to beat that in a matter of months anyway.
Yeah, I'm in the camp of, I think the spotter touched the bar. But the controversy is, like, you can't tell that for sure.
Right. Yeah.
But yeah, so that's it for Feats of Strength. Moving on to the next segment. This is the research review segment of the show. And Eric is going to do a research review regarding antioxidants and muscle hypertrophy. So I think probably a lot of people are aware of some of the literature looking at, say, high-dose vitamin C or vitamin E supplementation, and the fact that may decrease hypertrophy or signaling associated with hypertrophy. But this actually seems to be a somewhat more nuanced subject, an area of the research. And Eric is here with the goods.
Yeah, so this is going to be a fairly brief research review segment because it's not fully baked yet. And I think I might end up writing an article on this topic because the more I look into it, the more I'm like, ooh, there are some details here that require explanation and some deep thought. But what got me on this is there was a review paper that got published last month about antioxidants and hypertrophy. And unfortunately, I couldn't access the stinking paper. So I need to email somebody and try to figure out how to get that paper. But just seeing the title, I was like, maybe I'll do a little search of my own. So I start looking into, one of the things I was interested in is what is the proposed mechanism by which these high-dose antioxidants might be interfering with hypertrophy following resistance training. And I started looking at some papers, and one thing that jumped out to me was in a paper by Ito et al. In 2013. That's ITO. And what they were suggesting is that the mechanism pertains to peroxynitrite. And if you're me and you did a dissertation on nitric oxide, that is a term that has some significance for you. Basically, what they suggested was that peroxynitrite activates something called the transient receptor potential cation channel subfamily V member 1. And obviously, we all know what that is. I mean, that's kind of become a cliche in fitness. I'm kidding. I'd never heard of that in my entire life. But yeah, so basically, fun fact about that particular receptor is that it's also referred to as the capsaicin receptor. So am I suggesting that red pepper and chili pepper will make you enormous? I am. Yeah, one weird trick, capsaicin.
So Eric Helms, our nemesis, along with the country of the Netherlands,
yep.
He reviewed a paper for Mass, I think over 2 years ago at this point. It was one of our earlier issues about capsaicin and how it could improve. If memory serves on that paper, it was looking at repeated sprint performance. But it seemed to have fairly notable effects there. And the thing about capsaicin that a lot of people don't realize is that, like, you eat it It's hot in your mouth.
I think people realize that.
Yeah. Come on, Eric. I'm getting to the part people don't realize. Yeah. But like Eric noted, there is this receptor that is sometimes called the capsaicin receptor. And that's kind of everywhere in your body. And so when you eat hot foods, it not only makes your mouth burn, it also has systemic effects. And you probably experience some of those, like you feel like your body temperature is going up, you start sweating. I think a lot of people assume that that is just in response to your mouth burning, but that's actually due to the fact that capsaicin does have systemic effects. If you put capsaicin in a capsule, and so, it never burns your mouth in the first place, it will still have a lot of those same effects because it has impacts on, and I won't go so far as to say most, because I don't know if that's true, but a lot of tissues of your body beyond just your mouth.
Yeah, capsaicin is something that I'm going to pencil in some time to do a deep dive on capsaicin, because you look at it and you see it's implicated when it comes to thermogenesis, performance, as you mentioned.
Satiety.
Satiety was the one I was going to mention as well. And now potentially some mechanism pertaining to hypertrophy. It's just a really fascinating thing, capsaicin. Mm-hmm. So I want to look into it more and see how much of this is interesting, how much is useful, because it's not always the same thing. Mm-hmm. But in any case, this paper was indicating that the proposed mechanism was that peroxynitrite activates this particular receptor, which causes an activation of the mTOR pathway. And the idea was that high-dose antioxidants reduce the formation of peroxynitrite, and that might be this the mechanism relating to this apparent interference. And I mentioned, I've done some work with nitric oxide, and that's why peroxynitrite jumped out to me. If you look at the metabolic fates of nitric oxide, a lot of people know nitric oxide, you create it and it disappears almost immediately. Its half-life in the blood, the estimates vary because it's so small, but it's rare to see an estimate of more than a second or two in terms of like the half-life of nitric oxide. The question is, where does it go? And the answer is it could go a lot of places, but one of the metabolic fates is it is turned into peroxynitrite. However, that conversion is drastically reduced in the presence of antioxidants. And so the thing that's tricky is there's a little give and take here. So antioxidants shuttle nitric oxide toward other metabolic fates that in the short term would be more favorable. They essentially help recycle the nitric oxide into various different pathways that are acutely more favorable in terms of sustaining nitric oxide activity and theoretically enhancing performance. But it would appear that, from our current understanding, if you blunt that peroxynitrite production effectively enough, that might interfere with hypertrophy potentially. And so this is really interesting because we have known for some time that there is some link between nitric oxide and hypertrophy. There have been some rodent studies specifically that have shown if we give these really potent drugs that increase nitric oxide, if we pharmacologically really ramp up nitric oxide production, it seems to be quite good for hypertrophy. If we totally blunt its production, it seems to be quite bad for hypertrophy. So it's one more wrinkle that kind of enhances our understanding of the relationship between antioxidants and hypertrophy, but also between nitric oxide and hypertrophy potentially. Now, the solution here is kind of up in the air, but I think the solution is to look for some kind of a middle ground. So if we could have enough antioxidants that we are helping support nitric oxide production and function during the bout in a way that would generally be advantageous for acute performance purposes, but not have such a big dose of antioxidants that we totally blunt this peroxynitrite formation, that seems to me like it might be a very nice middle ground where we can still enhance performance acutely without interfering with training adaptations, because one without the other is there are very different applications of why you might use a nitric oxide supplement or why you might use an antioxidant supplement. Now, there is one study, a longitudinal study, looking at a nitric oxide donor supplement, and it actually was paired with an antioxidant, because people have known for quite some time that antioxidants do promote the bioactivity and the production of nitric oxide and help to maintain its bioactivity when it is produced. So there's a study by Huang et al. In 2018 out of Darren Willoughby's lab. They were looking at a product that was 200 milligrams of reduced glutathione, which is an antioxidant, combined with 2 grams a day of L-citrulline. Now, there are all sorts of caveats when interpreting this study. It's a nice study. It's a thorough one. It's one that I've read several times. Big sample size. They had a nice training program. Like they did things well here. Now, a couple of the issues. It's a very low dose of citrulline compared to the rest of the citrulline literature. Usually a citrulline dose, you're thinking it's going to be somewhere in the 3 to 6 gram range of the actual citrulline contribution. So 2 is a bit low, but I think what they were thinking is they were studying a pre-made formulation. So, I mean, it's not like they had wiggle room there. But I think also the concept is that when you pair it with the antioxidant, you can get away with a lower dose of the nitric oxide precursor. Now, the other thing is the antioxidant in the mix was glutathione, and the evidence is a little bit mixed in the literature about exactly how much oral bioavailability there is with glutathione. There are some papers suggesting it might be all right, others suggesting it's pretty poor. One of the big caveats, though, is the whole point of this study was to figure out if we give an antioxidant with a nitric oxide donor or a nitric oxide precursor, is it going to help with muscle growth? And probably the biggest caveat is nobody grew. Like, you look at the training program should have been a very sufficient stimulus for the accretion of lean mass. It's 4 days a week, upper-lower split, plenty of volume. It should have been enough to do the trick. And sometimes the way it goes in research is it just wasn't. So after accounting for changes in total body water, the placebo group increased lean mass by negative 0.8 kilos. The citrulline malate, there's 3 groups in it. One taking just a low dose of citrulline malate, they increased by 0.1 kilos, and then the citrulline with glutathione increased by 0.1 kilos. So, I guarantee when they were planning the study, they were thinking, okay, placebo group stays the same. Theoretically, we should see placebo group will grow because it's training, right? Mm-hmm. But then we'll see whether or not the glutathione and citrulline are having additive effects. And it would have been really cool if the placebo group grew, the citrulline group grew a little more, but then the citrulline with glutathione group really grew because the glutathione was helping nitric oxide essentially do its thing.
Or if, the placebo group grew, the citrulline malate group grew more, and the glutathione and citrulline group grew the same as the placebo, thus indicating that the presence of the antioxidant may have blunted the response.
Yeah, that would have...
Any sort of interaction between the supplements would have been neat.
Yeah, so when I say what would have been cool, that's certainly what the sponsor of the study would have hoped for.
Yeah.
Because their whole thing is they think that this inclusion of antioxidants is a novel thing to promote the effect of citrulline. But yeah, any of those outcomes would have been quite fascinating.
That's weird that they went with glutathione, though, because if memory serves, the reason that people take alpha lipoic acid is because it increases endogenous glutathione production. And I think it does have pretty decent oral bioavailability. So if these people are making a supplement professionally and putting it on the market, you would think that they would go with the thing that was actually tested versus the thing that may not actually get into your blood in the first place.
Yeah, it's true. I don't know what to tell you, man.
Fair enough.
It's a good point. Now, the question is, what do we do about this? Because like we have that one study that theoretically could have shed a lot of light on it, but it's just nobody grew. Stuff happens. I still think it's generally a good idea, as I always say, the default should be a relatively high nitrate diet just because of the numerous benefits of the fruits and vegetables that tend to be high in nitrate. Like, you're never going to regret the fact that you ate plenty of spinach and celery and berries and stuff. Like, you're going to be all right. If you want to go the nitric oxide route, I've got an article on the website about nitric oxide that goes to all the ins and outs of how it affects performance and maybe hypertrophy. I think you can at least say it doesn't seem problematic when the nitric oxide is paired with naturally occurring antioxidants in that food matrix. So like interventions with watermelon juice as citrulline seem to be fine. There are even some longitudinal interventions with beetroot juice where there obviously are antioxidant compounds in the juice naturally, where it does not seem to impair any of the training adaptations over 4 weeks. The studies I'm thinking of were looking at interval like sprint training, but it did not seem to impair muscular training adaptations at that level. I do think tentatively, until we figure out more, I think it does make sense to avoid super high dose antioxidant supplements if the purpose of the training is to induce adaptations, which it almost always is. Now, for acute performance instances, that might be a little bit different. But when we're talking day-to-day training, it doesn't seem like a super awesome idea currently to go with really, really high dose antioxidant supplements.
Eric, I have just a general question for you.
Okay.
Have you seen any literature comparing, I guess, like different kinds of antioxidants? So one of the things I've heard, which I don't know if this is true at all or not, is that the effects on training adaptations are different if you're talking like taking high doses of exogenous vitamin C or vitamin E versus if like your body's endogenous antioxidant system ramps up. So, you know, one of the adaptations to aerobic training, I'm pretty sure, is you get an increase in like endogenous production of glutathione and other endogenous antioxidants. So like, are you aware of any research on that? Or is that maybe just an idea that people have put forth that isn't really research? Like I honestly have no idea about that.
If I were to wildly speculate, I would definitely imagine there's a pretty pronounced distinction between endogenous versus exogenous antioxidant capacity, in the sense that I think it'd be very easy to exogenously just kind of flood the body with a lot of with a high dose of compounds with high antioxidant capacity that would exceed the adaptation you would experience of the endogenous system, if that makes sense. I think you could acutely manipulate the system to a much greater degree with the exogenous. So I would speculate that might be what's going on. I think one of the interesting questions would be, if you look at the types of antioxidants that exist, there are numerous. So to say antioxidants, like people who actually study that stuff are like, what, are you kidding me? Like, there are so many different compounds that fall under that umbrella of, you know, a quote unquote antioxidant. One thing that I would be interested in is looking at these very different exogenous sources of antioxidants, and do certain ones impair adaptations and do other ones not impair? And I don't know. I would imagine that. So when you look at antioxidant load, there are different assays to quantify the overall antioxidant potential of a particular food or ingredient or compound. And so there's a really good paper by Carlson et al. That was published in 2012. It has the antioxidant content, or the antioxidant capacity, of over 3,100 foods and supplements.
Jesus Christ.
So for all of them, they said per 100 grams, based on the assay that we think is most appropriate, what is their ability to scavenge reactive oxygen and reactive nitrogen species, generally speaking. So it's a really good resource, that particular paper. And I think one of the things that I'd be interested in is, aside from just total antioxidant capacity, do different types of antioxidants have different effects? Because they are very different compounds and are categorized accordingly. So I think we still have a tremendous amount to learn about how antioxidants affect. I think we have a good idea of their acute effects, but I think we have a lot to learn about their chronic effects in the context of a training program and how they might interfere with training adaptations. And I think that's going to come down to the dose. And by that, I mean the overall capacity to scavenge. And it's also going to come down to, I think it's worth looking at all these different types and how they might have potentially differential or even synergistic effects, possibly. But in the meantime, I think at the very least, we know that there are certain antioxidants that in very high exogenous doses, they do seem to inhibit some adaptations to training. I think we certainly know that they do increase the bioactivity of nitric oxide, but if that's at the expense of limiting training adaptations, that doesn't seem like a good trade-off if we're talking day-to-day training applications.
Yeah. So like, if anything, it could be the inverse creatine. We've talked about this before on the podcast, how folks kind of use creatine as like a model supplement, and aren't aware of all of its mechanisms of action, such that, we see creatine acutely improves performance, like reps to failure type stuff, like single session volume capacity. And people assume that, well, we know that occurs. We see that creatine helps improve training adaptations. Therefore, its ability to help you do more work is what's driving those things. You had a really, really good article about creatine for Stronger by Science, where you also looked through some of the other things that creatine does and other pathways by which it promotes hypertrophy beyond just acutely improving work capacity. And so it would be interesting if nitric oxide is the exact opposite, where, maybe if you do something to boost nitric oxide signaling via, adding antioxidants, it acutely improves performance, but has negative effects on adaptations.
And this is where the picture gets even more complicated, though, is because in the absence of those nitric oxide, or in the absence of a high dose antioxidant, if you introduce a ton of nitric oxide, theoretically that could also increase the production of peroxynitrite.
Yeah.
And so then it's like, well, what is the balance of increasing the nitric oxide for acute performance benefit, potentially even to some extent increasing peroxynitrite, maybe, but generally speaking, if you look at the literature, peroxynitrite is a bad word. You don't want runaway production of peroxynitrite. That's not something anyone would shoot for when it comes to the general.
Why is that?
Peroxynitrite is associated with damaging both proteins and potentially DNA and RNA in the cell. Generally not what you want.
So if I want to leave humanity behind, as it were, how much peroxynitrite should I aim for?
I don't think I can give you a specific dose.
More research is needed.
But yeah, so peroxynitrite,
whatever it takes, baby.
Peroxynitrite. That's one of the reasons why people. I think it's one contributing thing of why people say, "Oh, antioxidants are great."
Yeah.
It gets rid of all the bad stuff, right? Like antioxidants, people treat it like this anti-aging miracle because it scavenges a lot of these different things or reduces their production that are associated with damaging proteins and damaging DNA.
I mean, Linus Pauling was incredibly influential.
He was. But so the interesting thing is what's the balance where we have enough nitric oxide to acutely promote performance, enough antioxidants to increase its bioactivity without blunting the peroxynitrite, which appears to be promoting some of these training adaptations, including hypertrophy. basically it's a mess. It's a very complicated, interwoven web of factors. And the thing that I found most interesting about it was I was reading a paper purely about antioxidants, and I was like, this has huge implications for nitric oxide as well.
Mm-hmm.
So that's why I said it's kind of I wouldn't say a half-baked idea for the research review, but it's not fully baked because there's something there when it comes to the balance between nitric oxide precursors and the appropriate dose of antioxidant, either in that particular combination or in the diet overall. I think for now, it seems safe to conclude that super high dose antioxidants are not great for training adaptations, including hypertrophy. Peroxynitrite may be a particularly influential part of that. But in terms of the exact titration there of antioxidants in the diet, I just don't know yet. But certainly, I would not advise that anybody avoid getting dietary sources of antioxidants in moderate to high amounts. So eating a generally nutritious diet still seems like the way to go. But I mean, it kind of loops back to what we said about these, how my view of nutrition has gone from very mechanistic to ultimately defaulting toward good eating patterns.
Mm-hmm.
And it's like the mechanism is, like you mentioned, Linus Pauling. Some of these antioxidants and vitamins seem really nice. What if we took in like completely insane amounts of each? Like, well, it doesn't work out as well as we thought. And so I feel the same way in this particular instance of antioxidants. Should we just jam them in with training? It'll help with the acute recovery. It'll acutely increase the bioactivity of nitric oxide. Well, it turns out, once again, we kind of whiffed. It does seem to some extent, blunt training adaptations, including hypertrophy.
Mm-hmm.
So eat your vegetables, train hard. And that's all I got.
Sounds good.
All right. So I guess it was a few days ago now. The website Stronger by Science, an article went up by our very own Greg Nuckols. The article was called "The Evidence is Lacking for Effective Reps." And as we've done on the show previously, one of the cool things about the podcast is that after we publish an article on the site, we have an opportunity to see what the feedback is like. And the podcast gives us a great opportunity to clarify things, discuss kind of how people receive the article, any questions that came up from readers. So we do want to take some time to talk about this article. So before we get into that, Greg, can you explain what the general concept of effective reps is?
Yeah, so the nugget of the idea behind effective reps is basically for a rep of an exercise to promote hypertrophy, it needs to be close enough to failure that it's kind of hard. And the reason for that is basically a lot of the mechanistic work looking at what kicks off muscle protein synthesis and hypertrophy shows that it shows that your highest threshold motor units are probably the ones that are the most susceptible to hypertrophy. And so they're not going to be recruited unless a load is adequately heavy or until you're close enough to failure. So an implication of Henneman's size principle, which is just like a very foundational aspect of muscle physiology, is that as loads increase, more and more motor units are recruited. And then also with lighter loads, if you take them to failure, for the first few reps, most of just like lower threshold motor units will be recruited. And then as they start fatiguing and you get closer and closer to failure, more and more of your high threshold motor units will eventually be recruited. So, either doing reps with heavy weight or doing lighter weight all the way to failure, both of those things will eventually recruit all of your motor units. So the idea being that until you get pretty close to failure, you probably haven't really tapped into those highest threshold motor units. And then the other thing is most of the at least best characterized physiological pathways that initiate muscle protein synthesis and hypertrophy are related to muscular tension in some way, shape, or form. So essentially, there's little things there's spots where the muscle fiber is attached to the like connective tissue matrix that surrounds each muscle fiber and also runs through the muscle. And it seems like a lot of the actual like molecular pathways that eventually trigger muscle protein synthesis have a lot to do with those little adhesion points. And when tension is put on the fiber and it kind of pulls on those adhesion points, that activates like various kinases that then trigger the processes that eventually lead to muscle protein synthesis. So those are tension-based processes. So the idea is you need to both recruit motor units and then also expose those fibers to enough tension that it's going to kick off all of the hypertrophy cascade. And the notion here is that with weights that aren't like super heavy, so weights that aren't like 5 rep max or below, you're probably not recruiting all of your motor units from the first rep, and you can probably move each rep pretty quickly. And when you're moving a rep pretty quickly, you don't have enough time to form enough actin-myosin cross bridges within each fiber for there to be a ton of tension on the fiber. So basically, like if you're grinding a 1 rep max, or if you're doing like something plyometric, you're probably recruiting all or most of your motor units for both of those two things. But there's way more tension when you're doing the 1 rep max because the plyometric is very explosive. The shortening velocity is high. There's just not that much time for too many cross bridges to form to create tension, which is why, like, you know, if you grind out several sets of 10 to failure, you grow quite a bit. You do some jumps, you don't grow all that much. So that's kind of the idea, like the kernel of the idea behind effective reps. You need to recruit those high threshold motor units, and you need to get movement velocity low enough that each fiber can be exposed to a whole lot of tension. The idea some people have is to maximize tension on each fiber, which they propose will occur right before failure.
And this idea has gotten a lot of traction, right? Like you did a little poll on your Instagram the other day, basically saying like, essentially the question was like, how favorably do you view this effective reps idea? Was that essentially what you asked?
Yeah. So the original poll, I think, had two options. One was it's legit, and the other is it's bogus. And then like a bunch of people messaged me. It's like, oh, it's probably more complicated than that. It's like, dude, you can only give two fucking options for an Instagram poll. Like, calm down. So then I added another like slide to my Instagram story that says like, you can also interpret this as like mostly correct or like mostly incorrect. And I added that within like 30 minutes of the poll going up. But anyway, so like 2,500 people voted in that. And it was like 62% in favor of effective reps being a valid model and 38% against. And so there's various, like quite a few people have put forward various ideas for effective reps. Chris Beardsley's model is probably the most well known, so that's what my article was critiquing. But James Krieger has put forth a similar idea, Carl Junot, and I'm going to butcher his name, but I think you pronounce it Borge. But everyone calls him Borge because I think no one knows how to pronounce his name.
We're not the people to ask about it.
Anyway, so they've all put forth various effective reps-esque concepts, but Chris Beardsley's idea is the one that has gotten the most traction. And it is essentially the idea that the last 5 reps before failure are the ones that are effective. Those are the ones where basically all of the motor units have been recruited and there's going to be enough tension per fiber to trigger hypertrophy. And he has spelled it out in such a way that at least makes it seem that each one of those 5 would be similarly effective. So he's like gone through like different scenarios, like, oh, if you do, 4 sets to failure, or 4 sets 1 rep shy of failure, 4 sets 2 reps shy of failure, like this is how many effective reps you would get. And that very much makes it seem like it's not like, oh, maybe the rep before failure is the one that's actually the most effective, and like the 5 reps out is a little effective, but not as close. Like it's a pretty straightforward model where basically if it's within 5 reps of failure, it counts. If it's more than 5 reps out, it doesn't count. So like an implication of that is if you did 4 reps, or if you did 4 sets to failure, that would get you 4 more effective reps than 4 sets 1 rep shy of failure. You'd get 20 effective reps. So the last 5 of each set, if you did 4 sets to failure, you'd only get 16 effective reps, or the last 4 of each set if you did 4 sets 1 rep shy of failure. So another implication there is if you kind of do traditional strength training where, you're probably terminating most sets 2 to 3 reps shy of failure, then you would probably need to do 8 sets to get the same hypertrophic effect as 4 sets to failure. So just kind of throwing some concrete implications of the model out there. And so the thing about this concept of effective reps is it has some degree of mechanistic support. So for example, if you look at research where like people are doing isometric exercise at different percentages of maximum voluntary isometric contraction, it seems like working up to about 80-85% of MVIC, that's like the range in which motor unit recruitment does increase. And past about 80% or so, most of the further increase in force just has to do with increases in motor unit firing rates. And there's also some research looking at surface EMG for single joint exercises, finding that when you get about 5-ish reps from failure, for single joint exercises, EMG plateaus, and you don't get further increases in EMG as you get closer to failure. So EMG it's not like one-to-one the same thing as motor unit recruitment, but the two things do correlate reasonably well. And there's also like direct evidence showing that you do need pretty slow contraction speeds to maximize per fiber tension, essentially because the rate at which actin-myosin detachment can occur is like pretty variable, but the rate at which the rate at which detachment can occur is pretty variable, but the rate that attachment can occur is fixed and reasonably low. And so with really high fiber shortening velocities, you get like fiber detachment rates can exceed attachment rates. So only like a fairly small percentage of your like actin and myosin cross bridges potential are actually forming. But with slower contraction velocities, the attachment and detachment rates can match up better, and so you can get much higher per fiber tension. So anyway, that's the mechanistic idea. There is mechanistic evidence underlying that, and there is also some degree of experimental evidence to back this up. So the 2 studies that I think most people would cite as evidence for the concept of effective reps is one back from like 2004, 2005 by Goto et al., and then a more recent one by Martorelli and colleagues. And so in the Goto study, basically you had 2 groups doing 4 sets of 10. One of the group was taking those sets to failure, and the other group was taking like a 30-second break between reps 5 and 6 of each set. And so with that 30-second intra-set break, they weren't taking each set to failure because they were getting a little bit of rest in between. And in that study, they were doing knee extensions and they were measuring quad growth. And they found that the group doing those 10 reps straight through without the break in the middle did grow considerably more. It was like 2.5 times more. And then in the more recent Martorelli study, untrained women were doing bicep curls at 70% of their max. One group was doing 3 sets to failure. One group was doing 3 sets of 7, which would probably be 5 or 6-ish reps from failure. And one group was doing 4 sets of 7, which was like trying to match volume load with the 3 sets to failure group.
Do you think 7 is the least common number of reps to prescribe?
I think
Like in the
I think
history of
so.
lifting? I've never heard of someone being like, give me a good 7 here.
I don't see many fours either.
Oh, I do 4s all the time.
I don't think that many people do fours.
Don't talk to my clients.
I see a lot of heavy triples, and then of course 5.
Yeah.
But yeah, don't see too many fours.
I do 4s all the time, but 7s are off the table. I would never dare prescribe a 7.
Sure. But anyway, so in the Martirelli study, the increase in biceps thickness, I think, was like 18.5% in the failure group, like 8.5% in the 4 sets of 7 group, and like 2% in the 3 sets of 7 group. So pretty big difference there. So that's kind of like the evidence in favor of this effective reps model. But there are problems with it. So the research suggesting increased motor unit recruitment up to about 85% of 1 rep max, or about 5 reps shy of failure. Most of that is looking at single joint exercises. And you can also find it some with like multi-joint exercises with untrained lifters. But there's actually several studies using trained lifters doing multi-joint exercises, finding that the prime movers might be pretty close to full motor unit recruitment at considerably lower loads further from failure. So there was a recent study by Van den Tillar and colleagues looking at the squat, and it was looking at quadriceps, so I think every head of the quads except for the vastus intermedius. It was looking at quadricep, hamstring, and glute EMG with increasing loads, and found that with loads between like 50% and 90% of 1 rep max, for like the first rep of each set, quad EMG was the same. So there's actually modeling research by Bryanton and colleagues, using a measure called relative muscular effort, which is essentially the external moments presented by an exercise divided by the joint moments kind of measured in a single joint way that lifters can produce like in isolation. And so that study found that relative muscular effort in the squat basically didn't change with increased loads. And so that does actually seem to match with EMG as well. And so also in that study, it looked again at hamstring and glute EMG, and it did see that those were going up with increased load. And so the quads are probably, if you had to choose one prime mover in the squat, it is probably the quads. And so the prime mover, pretty high EMG from the get-go. Some of the like secondary supporting muscles, increased EMG as load goes up. Similar with an older study by McBride and colleagues. It looked at quad and hamstring EMG with 70, 80, and 90% loads. It found that quad EMG at 70%, pretty much the same as 90%. But hamstring EMG, again, was much higher at 90% than 70%. So again, prime mover EMG, pretty high, even at fairly low loads, like 70%'s reasonably low. But a secondary muscle, in that case, the hamstrings, ramping up as load increases. And then there was also a study from a couple years back by Kroll and Golis looking at increasing loads in the bench press. And it found that PEC EMG also basically the same between 70% 1 rep max loads and actual 1 rep max loads. But the EMG of the front delts, triceps, and maybe lats also did go up with increasing loads. So again, if you had to pick a prime mover in the bench press, it's probably going to be the pecs. Don't tell Louis I said that. But the secondary muscles, your triceps, front delts, those EMG is going up as loads increase. So it very well could be that kind of first assumption of the effective reps model that you do need full recruitment and you need to go pretty close to failure or pretty heavy loads to get that full recruitment. I think that is very much true with single joint exercises, but I'm not confident that that is actually true with trained lifters doing multi-joint exercises, especially if you're interested in the prime movers. So for example, if you're interested in squatting for hamstring growth, one, that's kind of dumb. Like, we've written about that on the site before. But two, if you were doing that, maybe it would behoove you to go to failure on every set. But if you're squatting for quad growth, you may not have to actually go that close to failure to stimulate your quads pretty well. And then the second assumption there, like needing pretty slow contractile velocities to achieve full tension on each fiber, I'm pretty skeptical of that. And the reason I'm skeptical of it is, so that's largely based on the load velocity relationship or the force velocity curve, where at higher forces, velocity is lower, at lower velocities, or at lower forces, velocity is higher. But that, again, is established under unfatigued conditions. So essentially, if you're having a fiber contract against increasing loads, as the loads go up, contraction velocity decreases. But under conditions of fatigue, it's not the exact same relationship. Under conditions of fatigue, if velocity is fatigue with the same load, just to be clear, as velocity is going down, force is also going down. Like, force and tension aren't increasing as velocity decreases, as you do, say, like a set of 12 to failure. Like, velocity is going to be lowest on the last rep before failure, but I don't think you can make the case that per fiber tension is higher. At that point, your fibers have fatigued. There's going to be some metabolites in there that affect the interactions between actin and myosin, and also, like, central drive is going to decrease. So the frequency with which or the frequency at which motor units or the motor nerves can reach depolarization and send signals to the fibers, like firing rates, that's going to be lower as well. So I don't think the lower velocities closer to failure during a set to failure with a fixed load indicates higher tension per fiber. I think it indicates that you can't produce as much tension per fiber. So if you're using high per fiber tension as a reason supporting the effective reps model, I don't think that you can make that argument in the context of a set to failure. So lower velocity is lower tension in that case, not the same as like the force velocity relationship with changing loads when you're fresh. So anyway, the biggest thing I'm trying to get at here is that the mechanistic underpinnings of the effective reps model, they make sense insofar as recruiting those highest threshold motor units and exposing them to a fair amount of tension. Those things make sense based on what we mechanistically know about hypertrophy. But the idea that you necessarily need to be within 5 reps of failure to trigger those things, I'm less sold on. I think you can get pretty close to full motor unit recruitment for the prime movers of multi-joint exercises quite a bit further out from failure. And I don't actually think you're maximizing per fiber tension as you get closer to failure. That doesn't necessarily mean that you don't get more growth closer to failure, but I think the idea that is what's maximizing per fiber tension and that is then what is promoting hypertrophy, I think the evidence in favor of that comes from studies on the wrong context, which is looking at unfatigued fibers with different loads versus under the influence of fatigue, taking the same load to failure. So in the article on the website, I would recommend you check that out because there's a pretty big part in the middle of the article where I also discuss a muscle fiber or a motor unit based model of muscle fatigue from Potvin and colleagues. And my understanding is that it is the most generally accepted motor unit based model of fatigue that is published in the literature. But it also doesn't make sense to discuss on this podcast because it's very, very visual and you will get bored as fuck if I attempt to explain it. And I would also do a terrible job explaining it. So the main point that I wanted to extract from the Potvin model is also just that, like, your very highest threshold motor units probably are never under maximal tension ever in any context except for like a maximal isometric. So we have longitudinal research from Morton and colleagues out of Stu Phillips' lab looking at fiber type specific hypertrophy with like training at 50% versus 80% 1 rep max. We see that both type 1 and type 2 fiber growth is pretty similar training at both intensities. But if you look at Potvin's model, like, there's a very low chance that most of your highest threshold motor units are getting anywhere particularly close to maximal tension, even as you approach failure with like 50% MVIC contractions. So I'm pretty skeptical that you do need to expose a fiber to maximal tension for robust hypertrophy in the first place. So check out the article, look at the Potvin model stuff. I'm not going to attempt to explain it in more depth than that here on the podcast.
So, I mean, generally speaking, it sounds like there are smart people who know their stuff who have talked about this effective reps model.
Mm-hmm.
And it's not that the entire thing is, completely off base, but it sounds like the problem is when people get extremely technical with the theoretical underpinnings or take the interpretation or the application extremely literally. Is that like a fair characterization? So like, because I mean, theoretically we would know with training, obviously we have to, if we're trying to induce hypertrophy, we have to apply tension to the fiber. We have to induce some semblance of fatigue.
Mm-hmm.
And that those two things are probably both driving some degree of hypertrophy, and that if you are doing these reps that are somewhere near failure with reasonably heavy loads, it's at least getting you in the ballpark, right?
Yeah, so I think something worth discussing is like why I wrote this article in the first place.
Sure.
And I think it's that 3 reasons, I would say. So the first reason is I rarely critique ideas that I don't think have much purchase with my audience. So, like, there's a lot of shit out there that I generally disagree with that no one, or that, like, maybe 2% of my audience would actually agree with.
You were a really late adopter for urine injections, for example.
Correct.
You didn't really get into it. You didn't write about it much until recently.
Right. So for the most part, I'm not going to critique an idea if I don't think that the people I'm reaching are the people who need to be reached with the critique of that idea. And so I know that the effective reps model of hypertrophy does have significant purchase within my audience. And so, I'm not just like crying out in the wilderness about something that no one in my audience actually believes, and that the only effect is just I'm preaching to the choir and I'm going to get kudos for telling people shit that they already agree with, So that's reason number 1. Reason number 2 is, so I start pretty much anything looking at the actual experimental evidence. Like, theories can sound good, but if it doesn't match what we've actually observed, it's you kind of have to go back to the drawing board, right? And so also in the article, I looked at the studies that had, to my mind, tested the effective reps model of hypertrophy idea the most rigorously. So these would be studies with like quote unquote normal training. So, not looking at rest paused or drop sets or anything like that, but just, normal multi-set training, with one group going closer to failure or to failure every set, and at least one other group staying further from failure than the other group, that are matched for intensity and either matched for total number of sets done or total number of reps done. And when you actually look at the experimental evidence, you don't actually see that much like direct tangible evidence for the effective reps model. So those 2 studies I previously mentioned by Godot and Martorelli, they do provide strong evidence in favor of the effective reps model of hypertrophy. There are 6 other studies that kind of investigate the idea, and they just don't support this concept. So there's 2 other studies on untrained lifters doing multi-joint exercises. One is by Sampson, one is by Nobrega. They tend to find no difference between groups going to failure or not to failure. There are some issues with those studies. The Sampson study, the non-failure groups were still doing 1 set per week to failure for load progression's sake. In the Nobrega study, the conditions not going to failure were basically going to RPE 10. So you essentially had 2 conditions that were actually failing every set, and the other conditions basically going to failure still. But so like there are those 4 studies in untrained lifters doing single joint exercises, and altogether they find that going to failure or closer to failure causes about twice as much growth. In just the Godot and Martorelli studies, which don't have those issues similar to the other studies I mentioned, it's like a 3-fold difference. So like that looks like pretty strong experimental evidence in favor of this model of hypertrophy, that like going close to failure and getting those reps close to failure does make a big difference. But then there are 4 studies on trained lifters that just don't support the idea at all. So there was a really recent study by Karsten et al. It looked at 3 measures of hypertrophy, one group doing 4 sets of 10 to failure, one group doing 8 sets of 5, not anywhere close to failure. It did find a significant difference in favor of the failure group for quad hypertrophy, but triceps and delt hypertrophy were similar between groups. The study that, or one of the studies that Eric Helms did for his PhD.
Who?
To be clear, different person than Eric Trexler. Eric Helms is not on this podcast.
Oh.
So one of the studies he did for his PhD, it was looking at RPE-based training versus percentage-based training, but he still got RPEs for people in both groups after each set. And the group doing RPE-based training was training like 1 to 3 reps closer to failure than the percentage-based group throughout the entire program. For bench press and squat, they looked at pec and quad growth, and it was similar between groups in spite of differences in proximity to failure between groups. A study by Pareja Blanco comparing training 4 sets of squats with a 40% velocity loss per set versus 4 sets with a 20% velocity loss per set. So basically, if you move the first rep at 1 meter per second, one group would terminate the set when they got to a velocity of 0.6. The other group would terminate when they got to a velocity of 0.8. So in effect, the 40% velocity loss group took like 56% of their sets to failure. They did a lot of reps that were grinders. The 20% velocity loss group, on average, I think the subjects only did like 10 reps during the entire program, where velocity was less than like 0.5 meters per second. So like they did basically no grinders, probably did virtually no quote unquote effective reps. That study looked at quad muscle volume and also fiber cross-sectional area in the vastus lateralis. No significant differences there. And then a recent study by Carroll was comparing one program where where one of the groups took the last set of every exercise to failure, mostly doing 3 sets per exercise. So probably one group like 2-ish reps one set 2-ish reps from failure, next set probably about 1 rep from failure, last set 2 failure. So fair amount of like quote unquote effective reps, versus another group that was training mostly like 2 to 8 reps from failure. So like not that close. So it was
8 reps is a lot.
Yeah. So it was basically one day where they were like 2 to 4 reps from failure. And so there were 3 days of training, but they only looked at quad hypertrophy, and the only like serious quad exercise in the study was squats. And so they were squatting twice a week. And so one group was doing 3 sets, terminating in failure on the 3rd set, both days. And then the other group was training like 2 to 4 reps from failure one day, and then like pretty easy the second day.
Okay.
And so in that study, they looked at full muscle anatomical cross-sectional area of the vastus lateralis. They looked at muscle thickness of the vastus lateralis, and they looked at fiber cross-sectional area for type 1 and type 2 fibers. The only significant difference between groups was anatomical cross-sectional area of the quads, which was in favor of the group training further from failure. And the other three measures kind of leaned in favor of that group as well. And so basically what you see when you look at the experimental evidence is in untrained subjects doing single joint exercises, the concept of effective reps tracks pretty well with the experimental evidence. Groups training closer to failure, doing more of those reps within 5 reps of failure, do see considerably more hypertrophy. And in the 2 studies that didn't have like was the other group actually training to failure sometimes issue, it was like a 3-fold difference in hypertrophy. Like that's pretty good. But then in the 4 studies on trained lifters mostly doing multi-joint exercises, there's no difference whatsoever. I think it was like in average for across like all measures of hypertrophy in those studies, it was like an average of like a 9% increase for the group doing fewer quote unquote effective reps, and like a 8.5% increase in the group doing like more quote unquote effective reps. So like, I mean, maybe it only applies to untrained lifters, which is something, but also probably aren't the people that are digging into like mechanisms of hypertrophy type articles on the internet.
Yeah, it's like I'm 3 weeks in, but I'd really like to learn more.
Yeah. And so that was the second reason. So I wanted to talk about this. 1, significant purchase within my audience. 2, doesn't seem to track that well with the actual like longitudinal experimental evidence. And then the third reason was that I don't think that we should have models that are more specific than what our current level of knowledge grants us the right to have. So essentially, if you have really granular evidence, then you can make a granular model based on that evidence. And we just don't have enough granular evidence to know that 5 reps from failure, that's the line, that's when reps become effective. And so like a soft version of the effective reps idea would be like, well, to maximize hypertrophy on a per set basis, you have to go at least kind of close to failure. I don't think anyone is going to argue that, you take 70% of your max, you do 3 sets to 12, or you do 3 triples, again at 70%, which is probably going to be like 9 or 10 reps from failure. I don't think anyone's going to argue that you're going to get similar per set hypertrophy there. I don't think anyone would. Like, everyone would argue, well, you have to go at least kind of close to failure.
Right.
If you don't go until shit gets hard, you're not going to grow, So, like, a soft version of the effective reps idea is that, well, you do have to kind of go close to failure to grow. But at that point, it's not an effective reps model. That's an answer you could get from literally anyone at the gym. Like, you ask them, how close do I have to go to failure to grow? Some people are going to say, got to go to failure every set. Some people are going to say, 2 or 3 reps from failure is probably fine. But no one's going to say like, oh man, to maximize growth, got to stay 10 reps away. Like, at that point, it's not its own model anymore. It's just shit that everyone already believes,
Right.
And so like the more specific version of the effective reps idea, that like reps get more effective as you get closer to failure, and it's really just those last 5 that count. We don't have granular enough evidence to confidently say that, and we have evidence contradicting it. So I have issues with specific models that are more specific than we can justifiably derive.
So here's my question. I spend more time keeping an eye on the nutrition and body comp related chatter, not as much on the training side. My outside observation was some period of time ago, everybody was obsessed with volume load, like their tonnage for their training. And then people started bringing up these hypothetical questions of like, well, what if I did that tonnage, but arranged it in a completely ludicrous way, such that nothing was ever acutely challenging?
Yeah.
did this just kind of evolve to fill that gap? Like to help explain like, well, no, you got to do something that's kind of tough.
Maybe. So not to toot my own horn too much, but I kind of think that Stronger by Science started changing that conversation back in 2013, 2014. We published a guest article from Nathan Jones that like was the first thing I saw that got pretty popular, and it went a little bit viral, arguing that, hey, volume load is dumb. Like, probably as long as sets are pretty close to failure, you can count hard sets, and that's going to predict hypertrophy reasonably well. So 2013, 2014, he did a good job summarizing the evidence that was there, but there weren't that many studies kind of to support or refute that idea back then. And then a couple years later, like either 2015, 2016, thereabouts, there was an explosion of research in that area, especially like high load versus low load stuff. And so I basically wrote like an expanded version of Nathan's article incorporating the research that had come out in the past couple of years. I think called the the quote unquote hypertrophy range fact or fiction ? And it incorporated like a lot more of the recent research, and it basically made the same point that volume load is dumb, and as long as sets are pretty close to failure, you can count hard sets. And so I think that's when the conversation started shifting. Like that's when I started seeing people talk about volume load, and then like a dozen people jump down their throat and say volume load's dumb, it's hard sets. So I think that effective reps is kind of a more granular version of hard sets. Like it's trying to quantify what hard is and kind of make the claim that going to failure does matter, is going to get you more growth per set than staying like 2 reps shy of failure. So I think it's just a more granular idea that is similar to the hard sets concept, but it is more granular in a way that's not fully justified.
Yeah, I mean, I shared your article, this most recent one, on social media, and someone kind of commented like, why not just do hard sets? Which, I mean, like, fair enough. Hard sets, it's a logical, I mean, it's a solid way to operationalize things. But I think this most recent article makes you consider the idea of, if you do hard sets, how hard should a set be? Mm-hmm. You know what I mean? Like, exactly how literally do we take this idea of effective reps and say, well, if you stop 2 shy of failure, that's objectively worse than stopping 1 shy of failure. Mm-hmm. You know what I mean? And so my response is like, yeah, you can do hard sets, and that's still fine, but how hard? Mm-hmm. And I think using hard sets as a framework and then diving into this article of talking about, okay, so how hard are we talking? Mm-hmm. I think you walk away from the article with a better understanding of, from a practical perspective, how nitpicky do we have to get about that proximity to failure when mm-hmm. programming?
Yeah, so the conclusion I basically came to is I think, like, as is often the case, the stuff that like big jacked people were saying 20 years ago is probably right. So like compound lifts, 2 to 3 reps from failure, probably fine. Like you probably don't need to push every set of compound exercise to failure to maximize growth on a per set basis. But you very well may need to go to failure for single joint stuff. So like, stay 2 or 3 reps from failure when you squat, then hop over to the knee extension and, fucking give it everything you got, And I think that's what the experimental evidence supports. Like the stuff on single joint training, going to failure does seem like a pretty big deal. Stuff on multi-joint stuff, 2 or 3 reps further from failure doesn't really seem to have much of an effect on hypertrophy. So probably don't need to take that. It's close to failure, which again, like that's what people have been saying for a long time. And I think it's probably mostly right. But yeah, so just to shift gears slightly, I think one of the like interpretations that came out of this article that I don't fully agree with, and something that I've seen like levied at me before, is that I'm like anti-training to failure. Because I mean the basic difference between the idea I like, which is hard sets, and the idea of effective reps is basically like, I say, yeah, I probably need to push everything to at least like 2 to 3 reps shy of failure. That's probably advisable, at least for hypertrophy, maybe not for strength in some contexts. But I mean, the main difference is just really, those last 2 or 3 reps to failure, like, are those effective or not? So I think some people get the idea that I am anti-training to failure, and I'm not. Like, I think it's quite useful in some contexts. And so I think the first thing training to failure gives you is, I think it's good for idiot-proofing your program against laziness. And so one of the things I see with some people, and we've talked about this before, is that when some folks use like RPE or reps in reserve based training, they're marking shit down as an RPE 8 that's just not. Like, you look at it, they still have like 6 reps in the tank. They never do anything remotely hard in their training.
Yeah.
And one of the things that's striking when you start reading research is you see a lot of longitudinal training studies that recruit folks who have an average of 3, 4, 5 years of training experience. They put them on a really basic program for like 10 weeks. And then they, like muscle cross-sectional area increases 10% and they get like 20% stronger on their main lifts. And if you're a strength coach and you've been working with someone for 5 years and they started with you when they were untrained, you're not getting their muscles 10% bigger and putting 20% on their lifts in 10 weeks. Like, right. It just doesn't happen. But these programs are really basic, but in the vast majority of research, all sets are taken to failure. And there's also research looking at how lazy most people are in most of their training. So Eric Helms, a distinctly different Eric than the one on this podcast.
I've met him, but I'm not him.
Correct. Yeah. Just to be clear. He reviewed a study from Mass like maybe a year and a half ago. It was a super straightforward study. They basically like plucked people out of the campus gym at some college and asked them, if you were bench pressing and you were doing sets of 10, what weight would you work with? And so one, like, those people probably exaggerated a little bit, just because if you ask someone how much you bench, most people round up, not down, But so they asked them, how much would you do for sets of 10? They told them a number. I think it was probably an overestimate, whatever. And then they brought them in the next day or like a couple days later or whatever, and just put them on a bench, like loaded them or warmed them up, and then threw the weight they did for sets of 10 on the bar and just had them do a set to failure. And I forget the exact numbers from that study, but I want to say like 40% of the folks did 16 or more reps, which, I mean,
oh, man.
Maybe they don't do bench press first in their workout and like they do some pre-fatigue stuff, or like they do 20 sets of bench and so they need to start with a conservative number for 10. Like those are possibilities, but no, I don't think that applies to most of them. Most people, you start a workout, if you're going to bench in the workout, bench is your first exercise.
Yeah.
Probably going to do 3 or 4 sets. So like, dude, a hefty chunk of the people in that study were just training lazy. Like they never did anything that I would call a hard set, or that probably anyone except them would call a hard set. But like they thought that that was an appropriate way to train bench press, So one of the things you see in the research is you take these people who claim to have prior training experience, make them start pushing every set to failure, and then magically within about 3 months, they get a lot bigger and a lot stronger. So I don't think training to failure is bad, but I think that it does idiot-proof your program against laziness. If you go until you can't do a rep, no one's going to say that that was not a hard set. So one, everyone would agree you need to train pretty hard to maximize growth. If you don't have much experience training to failure or any experience training to failure, that's a good way to make sure your program is hard. So that's the first thing I would say. You look like you're about to say something.
I was going to say, I have advice that people shouldn't take, but it actually is useful. It's just dangerous, so don't do it. But so when I bench in the gym, I never get a spotter, but a lot of times people will come up and ask if they can spot me. I'll be like, do you mind if I just spot you? Because I feel like you're going to die. And so I feel like that's a really good litmus test for like exactly how much are you shortchanging your RPEs. If people start offering to spot you and just be like, please, just let me keep an eye on you, it probably means you're pushing your RPEs pretty hard, that you're at least getting up there.
Yeah.
And then what you can do if you need a witty response and you want to say no, you just say, if I don't get the rep, I don't want to live to know about it. And then people think you're really tough.
Nice. And so the other thing that I would say pretty strongly in favor of training to failure is I think that if you do want to do submaximal training and use RPEs or reps in reserve to manage that, I think that there's value in spending some time when you do a lot of training to failure, just so when your program says, RP 8, 2 reps in reserve, you know what that fucking feels like. And I think that, if you've never gone to failure, I just don't know that I would feel confident that you accurately know when you're 2 reps from failure. Because I think that's a lot harder than a lot of people realize it is. I know. So for example, I have a fair amount of experience doing Shako style training. That's just feeding you triples at 80% and doubles at 85% until the cows come home. And a triple at 80% is not easy. You still have plenty of reps in reserve. For most people, it's probably at least 3 reps in reserve. For me, when I'm fresh, it's probably 5 or 6. But a triple at 80%, if you have a pretty high squat, it's not an easy set. Do 4, 5, 6 of those. You feel like you got a pretty good workout in. And when I get in Shiko mode, those, by the time I get 2 or 3 sets in, I'm like, fuck, this is hard. And I think part of it is kind of the mental grind. But at any point, I could just say, well, I'm doing a set to failure now and get 8 or 9 reps, So I think that if you... And I can step back and know that no, I can definitely do this next set. I feel the deep Shiko ache in my thighs, but I know I can do this next set. It's not actually that hard. I just don't want to do it. But I think that, yeah, if you don't have much experience training to failure, it's not that you're doing nothing if you're doing sets of 10 with your 16 rep max. It's just probably not as hard as you think it is. And you may think you only have 2 or 3 reps you could do, but you can actually do way more. So I think that there's value in spending some time going to failure just so you can accurately use submaximal training down the line. And then the biggest thing people will say against training to failure is that it's going to dramatically increase your injury risk. And I'm actually not so sure about that either. So I know that the hip thing to say these days is that there's no correlation between technique and injury rates whatsoever. I think that idea is maybe more true than some people believe, but I don't think it's completely true. I think if you go to failure, to true failure until you actually miss, for squats and deadlifts, week in and week out, that will probably elevate your injury risk. Some people are probably going to get mad at me because that's not a hardline enough statement. Some people are probably going to get mad at me because I said that there's any relationship whatsoever between technique and injury risk. But I just don't think your form breaking down going to failure on squats and deadlifts is a great idea. Fucking fight me. Anyways, so I do think that, like, in that context, yeah, training to failure may increase your injury risk. Form breakdown, you're squatting and deadlifting like 500 pounds with a bunch of spinal flexion. It's not good. But I also think that that doesn't apply to, like, pretty much any other lift. So, I mean, take bench press, for example. If you have a spotter, and so you don't have to worry about, like, crushing your sternum or rib cage or whatever, what's actually going to go that bad if you push a set to failure? Like, what like joint or tissue is going to be exposed to so much, like, extreme elevation and stress that bad stuff is going to happen? Or, like, fucking pull downs. What's gonna go wrong if you take a set of pull downs to failure? I think we can kind of get an idea of the fact that going to failure doesn't dramatically change injury risk just by looking at the injury rates, comparing strength sports and bodybuilding. So there's, I think, like 2 or 3 studies looking at injury rates in bodybuilding, and like 2, 3, 4 studies for powerlifting, weightlifting, strongman, like for each sport. And you tend to see injury rates for bodybuilding that's like maybe half an injury to 1.5 injuries per 1,000 hours of training. And for the strength sports, it's anywhere between like 2 and 5. And so, like, injury rates do pretty reliably seem to be lower in bodybuilders. And obviously, this isn't true for all individuals at all time, but I don't think anyone's going to give me much pushback when I claim that bodybuilders go to failure for a lot of exercises a lot more frequently than strength athletes do. And so I don't think the actual kind of like real world type evidence, like actually looking at injury rates, suggests that training to failure under most contexts is really that bad for injury risk. So I do think training to failure is fine under most contexts. I think it helps idiot-proof your program against not training hard. I think it's useful down the line if you want to do RPE and RIR-based stuff. I don't think it's ideal for strength development. I think that, you know, being able to get in high-quality sets, being able to do more of them by not pushing close to failure is probably going to be clutch. I think your training frequency and the amount of times you can practice a motor pattern in a week is going to be higher if you don't train to failure, just because it's not going to take you quite as long to recover from that training session. Like, I do think there are a lot of contexts where it makes more sense and you will probably get better results not training to failure, but I'm definitely not anti-training to failure.
All right. So if you want to take a deeper dive into some of the evidence we've talked about, if you want to get a deeper grasp on this entire concept of effective reps and what evidence supports it, what evidence maybe doesn't support it, again, that article is at strongerbyscience.com/effective reps.
Yeah, and just one very final thing I want to note about the idea of effective reps and Chris Beardsley's version of it in particular. This was in my outline and I forgot to say it on the front end. One thing I want to make clear is that my article is critiquing the version of his ideas that has gotten really popular online, which is a bit of a simplification of what it seems he actually believes about the topic itself. So I want to make it clear that I really like Chris. I agree with most of the things he has to say, and his actual ideas about hypertrophy are probably a bit more nuanced than what is getting shared on the internet constantly. So I want to make it clear that I'm critiquing kind of like the internet hive mind version of Chris's model and not everything he has ever said about the subject.
Okay, so to play us out. Now, to play us out, very, very upsetting news came down the line. On a previous episode, we mentioned that Ohio State, it's the football team that Greg and I root for. There's also a university associated with the football team. The university they applied to trademark the word "the," and at the time we were talking about it, it was still up in the air.
Well, it was the, correct?
I'm
Because
sorry,
it's
yeah.
not the Ohio State University.
Yes, the word is "the," and so they just got word back. The initial application has been refused by the United States Patent and Trademark Office. So some career politician bureaucrat, probably with a political axe to grind, probably part of the deep state swamp people, decided that they wanted to kick this application back and deny it. But hope is not lost. Ohio State says that they have several legal avenues that they can pursue. They're still on the case. They are going to make this happen. Okay, so it was a little setback. I wanted to inform people who were maybe waiting to hear an update. Yes, we had a small setback in the courts there, or I guess at the U.S. Patent Office. But
just to be clear, a setback in the courts, right?
Correct. Yeah, a setback in the courts. But the good news is we are still, when I say we, I mean the university, is still working hard to make that happen. And the other good news is Ohio State is 2-0 and looking great. All right. Thank you for listening to another episode of the Stronger by Science podcast. After the music, we've got an interview with Lauren Colenso-Semple. We hope you enjoy it. So, Lauren, you recently completed your master's degree with Bill Campbell over at University of South Florida. And now you're doing your PhD at McMaster, correct, with Stu Phillips?
That's right. So while I was working as a trainer, I sort of became aware of this area of research and connected with Brad Schoenfeld, volunteered in his lab for a bit, and he recommended Bill Campbell's program. So I was there for 2 years, and I've been in Hamilton for about a week and a half.
Very cool. How are you liking it so far?
It is an adjustment, but we're making progress day by day.
Very good. So yeah, I mean, what's really cool is if you kind of look back over the last few years, you've got quite a coaching tree that you come from in terms of your academic training. So you interned with Brad Schoenfeld a little bit. You did a master's with Bill Campbell. You did an internship with Andy Galpin over in California. While you were there, you made a pilgrimage to the Glute Lab under the tutelage of Brett Contreras for like a weekend. And then now you're with Stu Phillips in Canada. So that's a extensive list of really the heavy hitters in the evidence-based fitness side of things. So do you have a PhD topic yet?
I don't.
Okay, well, it's only been a week, so I guess that's fair. So
I've been focusing on things like getting an ID and getting my furniture, having health insurance, just...
It's kind of like the penalty that you pay when you abandon your country is you have to go through some of the unpleasant processes of reestablishing that stuff. Now, one of the things I want to talk to you about today is the study that you recently completed for your master's thesis. So the title, I believe, was High and Moderate Volumes Facilitate Similar Muscular Adaptations in Resistance-Trained Women. And full disclosure, I collaborated on this project a little bit. Frankly, I think I did kind of most of the work, but I'm still going to ask you questions to kind of lead the conversation along. So do you mind telling us kind of why this project? Like what inspired you to set out to look into this question?
So I actually went to the University of South Florida with the intention of doing this study. So if you can sort of put that in perspective, that was mid-2017, and volume was a very hot topic. I guess it still is. But at that point, there was really a lack of work in women, and particularly in trained women. So I kind of wanted to fill that void in comparing what we deemed a moderate volume to a sort of unreasonably high volume.
And so how did you go about kind of setting those volumes, like determining what was a moderate and what was a high volume?
First, I decided to just have the volume discrepancy be in the lower body. So we would just measure strength and muscle thickness in lower body sites So it was, although a full body program, very lower body focused. Just because I found that in some other studies, it looked like they were doing these full body workouts, but a lot of the exercises were not necessarily hitting the muscle groups that they were testing in any way. So I wanted it to be sort of as relevant to the test as possible. In terms of the volume, in terms of the number of sets that we established as moderate and high, that was basically looking at the moderate as what was then sort of the perceived upper limit, by which there wasn't enough evidence to determine whether you would continue to grow. At the time, Brad had just published a meta-analysis looking at, 3 sets is better than 1, 5 sets is better than 3, 10 sets is better than 5, but after that, we're not sure what happens. So the moderate volume group was performing 12 sets for the lower body 3 times per week. And the high volume group was performing what ended up being 81 sets total. So 27 sets 3 times per week.
So that's really high volume. How did the participants react to that kind of volume?
So it is high, but if you think about the other studies that describe this as sets per muscle group per week, then it wouldn't be as crazy. So this was a mix of compound exercises. They were doing squats, RDLs, hip thrusts, and leg extensions, leg curls, cable abduction. So it was a lot of volume, but I'll just kind of put that in context. In terms of how they handled it, it was a really wide spectrum of response. I'd say the moderate volume group was completely fine. They were in and out in 40 minutes. Some of them complained that it wasn't enough work. And then with the high volume, there were people who seemed totally unaffected by it, easily to recover, happy to show up every week, 3 days per week. And then there were people who were complaining, dying, etc.
Right. So just to get our heads around the methods here. So we're talking there are 37 resistance trained women, right?
That's right.
About 23 years old. And what was the definition for resistance trained there?
They had to have been resistance training regularly for the past 2 years and also have been squatting regularly for the past year. Okay,
cool. And so you're training them in the lab 3 days a week, right?
That's right. So 3 non-consecutive days a week for 8 weeks. The protocol, the exercise program was the same for each session. It was just that difference in number of sets. And they were not training to failure. We cut off each set 2 reps from failure.
Cool. And so the 3 days a week, were all 3 of those were lower body?
It was technically full body, but it was vastly lower body exercises as the majority of the program. And then at the end of the workout, they would do 2 sets of an upper body push and 2 sets of an upper body pull.
So going into this project, there's been several studies over the last few years of comparing different volume levels, specifically in male subjects. And I think by and large, kind of the prevailing theory is that volume seems to really dictate a lot when it comes to strength and hypertrophy gains. But then theoretically, there's got to be some kind of upper limit where the diminishing returns just get to the point where why bother doing more, So it sounds like you were kind of trying to do similar work in women and see like, okay, if we do like a pretty reasonable volume or a super high one, does the high volume stuff really pay off? Is that basically what you're getting at here?
That's right. And that was also the reason for having a fairly big difference. So the high volume group was doing more than twice the volume on a kind of weekly set basis than the moderate volume group. So we were really trying to push that and to see, does it plateau? Do you regress? And try to kind of hit on that point if it exists.
What are the kind of outcomes that you're looking at?
We measured muscle thickness using ultrasound in the front and the back of the thigh, and also the side. So you can think, rectus femoris, vastus lateralis, in the quad, and then hamstrings and glutes.
Okay, cool. And so, I mean, going into the study, what were you expecting to find with this big discrepancy in volume? Like, what was the hypothesis going into it?
I had a feeling that strength would not be different, and I was right. It was exactly the same in both groups, and the strength measure was a 6RM squat.
Okay.
I did think the high volume group would grow more.
And did that pan out?
It did not. We had one statistically significant finding in the lateral thigh in favor of the high volume group. But given the lack of difference in all the other muscle thickness site measures, I'm not putting too much stock in that, frankly. But just to sort of look at these types of studies as a whole, it's really hard to compare them because, for example, my subjects grew about 1% to 5% over 8 weeks. And you look at some other studies and there's way more growth in similar timeframes. So it's tough to see, well, what's the norm, or is it just how we're measuring it?
Do you think that was just because your subjects were more highly trained than most of the prior cohorts in the research?
I'm sure that had something to do with it, but even looking at some of the more recent work, the Schoenfeld paper that came out last year, the Barbalho, I believe that's how you pronounce it. That was all, and those were both in trained subjects, and the growth in both of those studies was just way, way, way more than what I witnessed.
So if not the training status, I mean, what do you attribute that to?
It's sort of a mystery to me, honestly. But in trying to compare this, I'm just seeing, a lot of it. I think it's tough to kind of reconcile the literature as a whole at this point. And I think part of that is some of the papers don't even report actual millimeter thickness. They're reporting just p-values or effect sizes. And the more recent work has started sharing, this was the pre, the post, the change. But the change over time in my study was very small. And that, honestly, I think that makes sense to me as a trained person, to let's say to add 10% to your quad in 8 weeks seems a little bit far-fetched.
Yeah, I agree. I see that all the time, and that's always the first thought that comes to mind. It's like, look, man, like I've trained a lot of people, and I don't see that many people who've been training hard for 2 or 3 years, like increasing any measure of muscle size 10% in 6 to 8 weeks. Like you just don't see that. Like you do have individuals occasionally who have results like that, but like group results, So it makes me think that occasionally the criteria are kind of lax. So, if they say we need someone to be training for 2 years, it's like, maybe if someone has kind of like gone to the gym on and off for 2 years, they kind of slip into the sample versus people who've like actually been training for 2 years,
Yeah, I mean, absolutely. And as you both know, recruitment for these kinds of studies is a challenge. And so although you'd love for everybody to be equally trained, that's just never going to happen.
I feel like that's something that is kind of lost on people that have never had to work through the logistics of doing this kind of study. But it's like the ideal scenario is you're going to find somebody that's super into lifting and has been training like crazy for hopefully years.
Mhm.
and is willing to hand over all of their training decisions to you for for a long period of time, and they know it's not even a personalized program. It's just like, well, you're either going to get A or B,
And they know it's not just that it's not personalized, but that it's not necessarily going to be like a one size fits all program that's attempting to be quote unquote optimal. Like, you're going into it with a hypothesis. Like, you got a 50-50 chance that you're getting the program that even the researcher doesn't think is great, you know?
Yeah, definitely. I mean, like Greg said, I think, what did you say was generally like the mean percentage growth you were seeing in your ultrasound measurements?
It was about 1 to 5%.
Yeah, I mean, if it was a 6-week or 8-week study,
8 weeks.
Yeah, if you promise me 3% over the next 8 weeks, like, I'll take that immediately. So, like, I think.
And just for context, we're so those actual numbers are things like a millimeter, 2 millimeters, sometimes a little bit more than that. But so think the thickness of 2 pennies. That's not visible growth.
Yeah. So after doing the study, being the person that ran it, I'm surprised you didn't call me out when I slipped in that comment that I did all the work, because I basically did none of the work. But I guess you're just going to let that slide. After going through all this and being there for all the training sessions, seeing how people respond to the training, like, what's your main takeaway in terms of like practical conclusions? When you look back at this, how can somebody actually use the results to inform their training?
Well, first and foremost, take all of these results with a grain of salt, because Eric did the statistics and I obviously need to redo them.
Shit!
The statistics are fine.
Mm-hmm.
We've got a world star moment about to go down here.
In terms of practical takeaways, I mean, one of the things that bothers me when people look at studies like this is they're looking for the paper to tell them what to do, to tell you how to train. And that's this really silly way to use this kind of use these findings, because one of the most interesting things about this kind of a study is you see, all right, this happened on average. It's not that interesting. But then you look at the individual response and it's really interesting, because you're seeing, hey, this program was great for somebody and terrible for someone else. And you see that not only with the muscle growth, but definitely with strength as well. You have somebody who got 5 pounds weaker and somebody who put 80 pounds on their squat. And part of that, yes, is I think training status going in, but there's clearly also this question of volume and other variables. It's not one size fits all. So I think as an individual, these papers give you maybe a general place to start, or as a coach, right? But then if you're really looking to optimize your own programming, then it's experimentation to really find what works for you. You're not getting that from a paper.
I do have one question. So did you kind of like, I don't know, informally jot down or like take notes of which individuals on the high volume program were really struggling versus which ones seem to be more or less doing fine? Because I would be interested in whether there would be a difference between those folks. Like, my kind of mental model here is that more volume is better as long as you can recover from it and it's not just beating you to shit. So like, I would kind of think that the more interesting variable isn't necessarily volume itself, but kind of like how people are responding to the volume. So like, I would think the people who were beat to hell from the high volume would probably not do better than the moderate volume group, or perhaps even do worse. And then the people who were on the high volume who were handling it quite well would probably do better than the moderate volume group. Like that would be kind of my rough hypothesis. So I'm just wondering if you like jotted that down anywhere for kind of like an informal analysis.
Sure. I mean, it's hard because there's so much that goes into it that we have no control over.
Oh, for
Things like
sure.
lifestyle, stress, sleep, all of that. We don't have the resources to closely monitor all of the variables that are going to go into recovery. Um, but I would say a lot of it was outside stress. So it seemed, the people who just had more going on in their lives. This is, not shocking, but the students who were students and had jobs, and were maybe in a difficult major, they tended to be having a harder time with the high volume, whereas some of the other students who maybe didn't have as much going on in life were able to handle it better. But that's a really loose statement and I'm probably not that helpful.
No, I got you. That makes sense. And so like if you did kind of find what I'm hypothesizing here, it would be like kind of a two-way interaction. Like was it necessarily the greater volume that's doing it, or is it just they were the ones that had lifestyles more conducive to getting good results? So ultimately, it may not mean anything.
I should mention we also assessed salivary cortisol at baseline and post 8 weeks. And I have not yet looked at the cortisol levels in comparison to maybe the progress that they made on each program, mostly because my statistician didn't get me the results until late last night. But
that's insane. You texted me at like 5 and said like, here's some cortisol data. How do they look? I did them and like immediately dropped everything. Except
that I emailed them to you 2 weeks ago.
Yeah, but I didn't care at that time. if you had emailed them to me and texted me and said I need these now, then I would have done them then.
It's interesting that then I'm coming on your podcast today, so all of a sudden I have time to prioritize my cortisol.
Listen, the stats are fantastic. These are incredible stats. You've never seen stats like these, so I think you should be happy that you got them so quickly. As far as I'm concerned, the turnaround time was like 3 hours.
Moving on. So, what was interesting though, just at first glance, is the range of cortisol levels. So, it's my understanding that maybe an average in kind of young people, it would be about 20, and they ranged from 5 to 35 in our subjects, which was pretty astounding.
Yeah, and cortisol is just such a tricky hormone. I mean, when we've used it in previous studies I've been involved with physique athletes throughout prep and recovery, and there are just so many things that influence it. I mean, you can get some pretty wild numbers with cortisol just from, I mean, the way you view it as a researcher is you're simply looking at physiological stressors, but like you can't control the fact that somebody had a breakup 3 days ago and they've got a final exam in 2 days. And yeah, cortisol numbers can just get pretty wild pretty quick depending on these other stressors that in many cases are extraneous to anything you can control.
Or just that it's someone's first time ever being in a research lab and they're nervous.
Sure.
Yeah, definitely. That's not to be overlooked.
And so the simple fact that we're just measuring it once throughout the day is for sure a limitation.
Yeah. Now, I think when people look at the literature comparing all these different volumes, there's been a lot of studies over the last few years that kind of fit that paradigm. Generally speaking, I mean, what's your take on when you have you have somebody that maybe you're going to coach and they come to you and say, all right, let's start me with a program. What's your view on where to set that volume getting started?
I would err on the side of lower, unless they're already doing more. But I think we all make the mistake of doing way too much, way too early on. And it's just another opportunity to get injured. It's probably not helping you progress any faster. If I can grow doing 5 sets a week, then I should do that for as long as it's working and then make the adjustment instead of unnecessarily doing 35 sets a week.
Yeah. And so do you think that this relationship with volume and growth and strength adaptations, do you suspect that this is because you set out to do this study in females who tend to be underrepresented in this field in terms of research participants? Do you suspect that those guidelines differ between men and women?
I think that we don't know that yet. I know there's a fair amount of speculation on women can handle more volume and women don't need to rest as long. And I don't know that all that is very conclusive. And I'd say that sure, on the individual level, there seems to be a big range of what's going to work for you. But I don't think there's enough studies comparing trained men and trained women on the same protocol. And so it's kind of hard to compare apples and oranges with, one study with trained men and one study with trained women.
No, I agree. One of the really striking things when you look at the literature is like how many research questions have a ton of studies in men and like no studies in women, or like maybe one study. So like, for example, the low load, very high rep training versus more like moderate load, like sets of 8 to 12 type stuff. Until there were 2 more studies published in women like 2 or 3 months ago. But until then, like there were like 14 studies in men, and there was 1 study in women from back in like 2009. So like how can you, like there was a body of literature in men that you could draw conclusions from, and then like 1 study in women that you had to look at and be like, well, hope they did that one right. So yeah, like that's definitely a good point. A lot of what we know, we just kind of think / hope that what we've learned about in men carries over to women as well. And in a lot of cases it does, but there's just not as much research on women to be able to make that comparison like you're talking about.
Yeah, our paper we published recently out of Andy's lab, we were looking at the fiber type in these elite athletes, men and women. And there's this sort of prevailing thought that women possess more type 1 fibers. And we didn't find that in these kind of elite athletes. So I think there's, and not to say, oh, well, everyone else is wrong, but with fiber type analysis, there's a lot of nuance based on the particular technique that you use. And so I think that some of that and probably some other kind of assumptions of sex difference will continue to evolve as we do more research and as we also kind of refine our techniques for analysis.
Now, I'm glad you brought that up, because this summer you went out and interned in Andy's lab. And I know looking at that paper, you make a big distinction between 2 different ways to do this fiber typing analysis. So there's the homogenate composition and then the single fiber kind of method for analysis. Do you mind explaining that to me as if I were an idiot?
Sure. So
hypothetically,
this was a really totally hypothetically. My experience in Andy's lab was really valuable because I think even if you're somebody who reads a lot of papers where they're reporting fiber type distribution, it's tough to truly understand, well, do we care that one of this was homogenate and one of this was single fiber, and can we compare those papers? Can we group all of this fiber type findings together? And the answer is probably not. So with the homogenate, you're basically taking the sample and grinding it up. And so you have multiple different fibers and subsequently fiber types within that particular sample. So then we're looking at separating that mixture of proteins based on molecular weight. And the homogenate quantifies sort of the percent area that is occupied by your type 1, type 2A, and type 2X. It does not distinguish between the hybrid fiber types. So if you think of this actually being on a kind of spectrum of myosin heavy chain content, then you're going from the type 1, which is slow, to the type 2X or super fast. But along the way, you also have these hybrids. So you have these a type 1 / type 2A and a type 2A / type 2X. And the homogenate can't identify those hybrids. And so it tends to overestimate the type 1 and the type 2X.
Yeah, I think that's an awesome point. Just to interject, I don't think a lot of people are aware of the continuity in muscle fiber typing. You know what I mean? I think a lot of people think there are these three very neat bins of 1, 2A, and 2X. And the whole concept that we're really looking at more of a continuum than three completely distinct things, I think is lost on a lot of people.
Well, that's because all of the like exercise physiology textbooks that you learn in undergrad are based on research from like the fucking 70s, man. I don't think that's a blind spot for people who aren't trying to educate themselves. I think that's people just assuming that textbooks are much more up to date than they are. Like, I know that's what I thought until like I said something and then Andy Galpin like saw what I posted and probably could have torn me a new one, but was way more polite than I probably deserved. He was like, check out my 55-minute physiology videos on this topic. And I did. And it just blew my mind because like I had been told for the past like 5 years that like, hey, this is how it is. And that's how like all of the basic textbooks lay it out. And that's, you know, an understanding that's outdated by a solid 30 years.
I think there's also this, I think it's represented as if, oh, this fiber is type 1, period, end of story. But there's no explanation of what does it actually mean to be type 1? And if it's type 1 today, does that mean it's type 1 forever? And that's another sort of interesting body of work right now, just showing the plasticity of the fiber type, you know, that especially with training and also with an unhealthy lifestyle, you can go in either direction, right? But you're getting these shifts of fiber type. So somebody who does a lot of endurance training, for example, in their lifetime will, when biopsied, have many more type 1s, whereas these elite kind of strength and power athletes have a ton of the 2As.
Yeah. Now, I often hear people saying that they're like, oh, I want to train so I can get more 2X, you know, because 2X is the biggest and the most explosive. Is there any reason that somebody should set out to do that?
No. So, I mean, in fact, that actually goes back to comparing the homogenate to the single fiber, because the homogenate only quantifies 1, 2A, and 2X, then it is sort of inappropriately identifying what is in fact a 2A, 2X hybrid as a pure 2X. So when we analyzed the fiber type distribution in these world-class Olympic weightlifters, there were no type 2X in any of the athletes when we did the single fiber analysis.
Yeah, I mean, I used to always tell people, if you want to get more 2X fibers, just stop moving entirely or go to space. Because, I mean, that's really the kind of the fiber type, at least from what I've been taught, that you get essentially from extensive detraining. Like, when you extensively detrain, we tend to see more of those 2X. But in someone who's otherwise mobile and especially doing any kind of training, they really don't seem to be very prevalent, do they?
Yeah, so really, and again, now with being able to identify these hybrids, you're seeing the vast majority of these 2A, 2X hybrid fibers in sedentary people, in diseased populations, in overweight people, whereas you're going to get more of the pure 2A in somebody who is an athlete, particularly a strength or power athlete. But
Yeah.
Really, though, with the development of this sort of ability to identify those hybrids, we don't see 2X anymore. But if
Even in sedentary people?
That's right. You're seeing a lot
Wow.
of the hybrids, but going back to the homogenate, again, there is no ability to see that. And so then it's going to be classified as 2X.
Okay, so you mentioned with the homogenate, basically we go in, we take a muscle biopsy, we grind it up, and then we kind of sort it out from there. So how does the single fiber technique, how does it differ from that?
So with the single fiber, you're actually separating out with tweezers under a microscope each individual fiber. It's like teeny tiny strands of hair.
Okay.
It's very time consuming work. But basically you're taking, with each fiber that you were able to tease out, then you put that in a test tube, and you are only looking at the fiber type itself of that single fiber. So essentially when it's reported in a paper as 30% or 50% or whatever it is, then that's expressing the frequency of that particular fiber type in a given sample. So let's say I separate out 100 fibers, analyze all of them, how many of those were type 1, then we're saying, okay, this occurs this often. But the sort of downside of that analysis is that you're not able to identify the area that it's taking up. We're only able to say, oh, this is type 1, type 1, 2A, etc. Whereas the homogenate, it's all about quantifying area.
Okay, so I have a quick question. So I get that the single fiber analysis is much better if you want to know kind of granularly what each of your fibers actually looks like. But in terms of like, I guess, being able to guess or predict something about performance, I wonder, does it actually matter? And I don't say like I wonder as I'm leading you to an answer. I say I wonder as in like I actually wonder, because I don't know too much about this. So basically, like, let's say someone has 50% type 2 fibers, and looking at the homogenate, it's, like 40% type 2A myosin heavy chains and 10% type 2X, versus when you do the single fiber analysis, you see it's like 30% pure type 2A and 20% 2A 2X hybrids. So like both kind of work out to the same thing, but like does one or the other tell you anything different about what sort of performance you could expect from that athlete? Or is it just that the single fiber kind of gives you more granular information if you want to do like research on like fiber type shifts or something like that?
Yes. And I think especially just to bring up those hybrids again, when, for example, if you're a sedentary person with a ton of those 2A, 2X hybrids, and then you start training, then those will shift to pure 2A. And so that has some kind of implications for overall health, potentially. In terms of performance, we, in our group of, like I said, these were elite, kind of best weightlifters that there are. They had a ton of 2As, as you would expect for strength and power athletes. But when you compared on the kind of individual level, their particular fiber type distribution to performance, it was not a predictor at all.
I gotcha. So basically for kind of like health implications, the just percentage of hybrid fibers is kind of an indicator that, okay, maybe this person doesn't exercise much. And if someone has very few of them, they probably exercise more. But beyond that, it's not that huge of a deal. Like, am I understanding that correctly?
Yeah, I think it depends on the sport.
Okay.
So for it might be like the having more type 2As might be more beneficial if you are doing something like Olympic weightlifting, where you have to move a lot of weight very quickly. So the idea that it's not necessarily about how strong you are, but more about, or say more speed than force production necessarily, that might help. But the idea that, oh, you currently have 60% 2A, should you be striving to get 65%? Like, you will have more 2A, period, just from doing resistance training. And so I don't think it's a particularly good measure of performance, especially when you're comparing one trained person to the other.
And it's worth pointing out, in this sample, you had 6 world-class female weightlifters, and then in terms of like national caliber, it looks like 9 females and 6 males. So we're looking at how fiber type related to performance, but in a sample that was already tremendously well trained and competitive, right?
That's right. And so it's basically just saying, okay, well, once we get to this, we were trying to see what makes you world class, right? Instead of the national. Is there something that we can see here is it about the fiber type? Or is it just that your training history is probably shifting the fibers in one direction or the other? And so it seems more like, hey, these more seasoned athletes who have been training for longer have higher percentages, not, oh, the strongest competitors have the most 2As.
That makes sense. So when people talk about fiber type shifts, what time frame are we probably talking about here? So, like, if someone starts with like 30% hybrid fibers, at what point? So I guess 2 questions. So, like, one, at what point, like, how long would someone probably have to train to get it to where they pretty much have pure fiber types with not that many hybrids left in the mix? A, and then B, at what point has the fiber type shift kind of run its course? Assuming you train kind of the same way over the course of a training career, like how long does it take for those adaptations to be fully realized?
Well, there's not a huge amount of work here, but there is some in that you actually can see these changes in just a few weeks, at least kind of preliminarily. But the most dramatic change would be if I take somebody who's a marathon runner and he starts powerlifting or Olympic lifting. And vice versa, right? Because you have that much more room to shift. In terms of what happens when you keep training like that, it's again dictated by the training. So assuming you experience the shift and then continue to train in the new way, then I'd say you're likely to maintain those adaptations. But for most people who end up going through kind of phases of less training or switching up what they do for exercise or just getting a little bit more sedentary, then you would have the shift back potentially, or the shift to the hybrids.
I gotcha. That makes sense.
Another sort of interesting note with that sample is there was this really startlingly high number of percentage rather of the 2A, 2X hybrids in the heavyweights, and so, but not in the other weight classes.
Interesting.
And there's really not a lot of research on kind of obese but highly trained athletes. So that is interesting.
What do you make of that observation?
Well, I think it's sort of is in line with we're seeing these in more sedentary or in more diseased populations. But then you have to say, well, but then does it matter? For if you're also seeing them in these, I mean, I'd say fairly healthy, or at least in terms of performance, right?
Yeah, because I mean, looking at the numbers, it looks like the heavyweights accounted for 91% of the 2A2X fibers that were found within the whole sample.
That's right.
I mean, that is a huge number.
And
That's
so I
crazy.
think it's really we could say that it's both training and kind of body mass that is the predictor of these of the fiber type distribution. But I think what's more interesting is that having all those hybrids doesn't appear to affect their performance. It's
Yeah, I mean,
be part and parcel of being that heavy.
yeah, I feel like the more I'm involved in this conversation, the more I'm like, man, we need to start like updating some textbooks. You know what I mean? Like, I mean, Greg already alluded to this, but just the things that I've been taught, and like, I'm not a dinosaur. I finished grad school like 5 months ago. It's not like I'm like relying on, some dusty old textbook that's out of print. Like, we need to update this stuff, because it sounds like we're learning a lot about fiber type and kind of improving the methodology quite rapidly. So it's kind of crazy that you can talk to somebody and think that you have a good handle on this stuff, and then realize like there's a lot more to this than what's being kind of currently taught, even at high levels.
Sure, and I mean it's evolved a ton. I mean, at least you're not seeing 2B fibers anymore in most textbooks, but still in
Yeah.
some,
Yeah. That's like the source of confusion that will never go away, is like the 2B, 2X thing in terms of nomenclature. It will just
Yeah.
always persist and always be present and annoying. So when an athlete worries about their fiber type, like if an athlete's like losing sleep over whether or not, let's say they're an endurance athlete and they're like, I hope I have a ton of type 1 fibers, but I just don't know. Or if they're an explosive athlete and they're just like praying that they have a bunch of, super fast twitch fibers. Do you think it makes a lot of sense for people to worry about that? Or like does it seem to really be, in the big picture, an important determinant?
Well, I think what we don't know is how much is dictated by what you're born with and how much is dictated by training. So we really just need to biopsy a bunch of newborns and then follow them throughout their life and continue to biopsy them.
Good luck with that. That's going to be tough.
Sweet. I'm all for that.
I think it's silly to worry about it, because what are you going to go get a biopsy? Are you going to get them regularly? Are you going to pay for somebody to analyze your fiber type shifts? Like, you're much better off just focusing on your performance.
You never know. People are doing DNA tests in the mail these days. I mean, we could pop open a lab and, open up the doors, make some money.
That's true.
Yeah. One of the, so there aren't that many papers looking at this, but I remember back in the day reading some of like Poliquin's old stuff, and the idea that the way you could know whether you were type 1 or type 2 dominant was take 80% of your max, do max reps. If you get substantially more than 8 reps, you're probably type 1 dominant. If you get like 4, you're probably type 2 dominant. And like 8 was kind of the bright line, where more than 8 type 1, fewer than 8 type 2. And there have been like 3 or 4 papers published looking at that with kind of like a rep max test, and then kind of looking to see whether like percentage of type 1 fibers predicts how well someone is going to do on a rep max test like that. And they basically find that like, yeah, there may be some sort of a relationship, but you're dealing with R squared values of like 0.1 or something like that. So that kind of makes me think that, very much like you're saying, like it's not that fiber types are irrelevant, but I think it's definitely possible to worry too much about them. And if the amount you're worrying about them extends beyond like I'm like a national level athlete, and like, do the international people maybe have a leg up on me that I can't have access to? Like, okay, well, maybe then it could become relevant, but for most of us, like, it's not predictive enough to really lose sleep at night about.
Unless we could do like fiber transplant. If we can inject
That would be
you
cool.
with like a bunch more type 2 fibers.
I know in vitro research, you can induce like complete fiber type shifts by stimulating a motor nerve at a particular frequency, and like high frequency stimulation will make all of the fibers downstream of it type 2, and low frequency stimulation will make all of the fibers downstream type 1. It makes me wonder if you could perhaps have a model with like kind of high volume e-stim over the period of several weeks to induce like very profound fiber type shifts within individuals, and see if that changes any like functional characteristics. But I don't think anyone's actually seen whether that principle still applies in vivo or not.
Yeah, I mean, I think you're looking at way bigger muscles. So
yeah.
even if that worked at sort of a micro level, but you could sell some gimmicky product. I think you're onto something there.
That's the only kind of product we sell. Now, Lauren, you recently had a review paper come out with Robert Morton and Stu Phillips, and you guys kind of laid out, it's called Training for Strength and Hypertrophy, an Evidence-Based Approach.
Mm-hmm.
And you guys kind of just summarized the resistance training data that's available to date and kind of put it into some practical takeaways. Since you're a coach, rather than having you kind of rehash the whole paper, the paper kind of talks about frequency, intensity, and volume guidelines. Now, you just ran a big study in a bunch of resistance trained females, looking at different volume levels. When you basically get a new client and you're starting from scratch, you don't know a ton about their training history, you basically have to set out frequency, intensity, and volume guidelines. Where do you typically start with somebody that's new?
I think when you're coaching someone, you need to tailor it way more to their lifestyle, their desires. So it's if what I thought was quote unquote optimal, but it's not feasible to you, then it's kind of a silly recommendation. So I think really though, the big take home is that a lot of this can be tweaked based on preference. For example, if somebody wants to do really high frequency training, and spread out their volume over the week, then I think that's fine. If someone wants to go to the gym for longer 3 times a week, that's probably just as fine. So I know that's kind of a boring answer, but I think a lot of this literature where we're looking at like optimizing this and that, it kind of gets lost of, wait, so does everyone want to spend 2 hours in the gym? Does everyone want to do 25 sets of squats a week?
Yeah, so every client is basically, you start out with a blank slate. You basically start with the basics, like how many hours a week can I get you to train? How many days is that going to be over? And you just kind of reverse engineer it from there.
Sure. I mean, generally the people I get are already lifting. I'm not working with brand new people. So I look at really, what are they doing now? What are their goals? How are they recovering? And we can kind of tweak it from there. But I think it just isn't a one size fits all thing. A lot of people that goes for volume, that goes for exercise selection. I think there's a lot of dogma in terms of, everyone must bench and everyone must deadlift. And it's like, they're good exercises, but not everybody has to do them. So looking at what the person likes and what's appropriate for their goals, I think is really, I feel like I'm not adequately answering your question.
No, I mean, it kind of comes back to like your impressions of the study that you ran is like, I could, give you a perfectly conducted statistical test comparing high volume versus moderate. But what you don't see there is that for some people, the high volume approach would have been ideal. For some, the moderate would have been ideal. And for a lot of people, it probably should have been somewhere between, So I think a lot of people look to the resistance training literature thinking that they're going to look at singular studies and aggregate them and get kind of a blueprint.
Mm-hmm.
When in reality, it's more just kind of showing you workable ranges or effective zones that you can kind of operate within.
I think it's also important to point out that this is just 8 weeks. And for the most part, you're just looking at a month, 2 months, 3 months of training. And so even if it was great for those 8 weeks or for those 12 weeks, that doesn't mean you should always train that way.
Yeah, I kept telling Bill that he should have extended your project, make it like a year or two, but he just wouldn't listen.
Yeah.
Now, do you have any like certifications outside of your degrees?
I do. I have a CSCS and from the NSCA, and I have a sports nutrition certification from the ISSN, and I think they might be expired now. But once upon a time, I was a NASM trainer and ACE group fitness and kettlebells and TRX and prenatal and all that stuff.
Right. Yeah, I don't care about any of that though. You're certified with no,
were you just setting yourself up to say that, Eric?
No. I have a pertinent question. Those are fine organizations, but not relevant to my interest right now. Now, you hold a certification from the Wine and Spirits Education Trust. Is that right?
I do.
What is that?
So that is the certifying body for sommeliers.
So you're a certified sommelier?
I'm not. I didn't go all the way. You have to, it takes years. You have to do many courses. So I have the level 3, and I'd have to do 2 more levels in order to then take that test.
Oh, is level 3 like the lowest level?
Level 1 would be the lowest level, but thank you for that.
But you have to get up to what, level 6? Level 5?
Level 5, yeah. So basically it's courses where you learn about wine and spirits and you taste them and then you take a test.
And is that the certification that you're most proud of?
It is. I highly value my knowledge of wine and spirits.
Have you seen the movie Sideways with Paul Giamatti?
Yes.
How true to life is that movie?
It's fairly true.
Sick.
But there's like levels of snobby, right? So it is true that you can smell and identify different types of grapes and even different regions. That's actually when you take the test, you need to be able to identify the region. And if you're going to be a sommelier, you even need to be able to identify the vintage.
That's wild.
Yeah, yeah.
And so which wine would you pair with seaweed if you had to like choose one? So Greg, a little inside information. There was a time where every time I like checked in with Lauren to see how she was doing, she was currently basically living off of seaweed and wine. It was like all she ate for like 4 months. So
you said
are you still
seaweed?
on seaweed? Yeah. Are you still on the seaweed and wine diet?
I haven't had the seaweed in a while. I haven't even thought about the seaweed. They were good. They were like these seaweed thins is what they were. Yeah.
Yeah, just like chips made purely. It's just seaweed, right?
It's just seaweed with some other spices on them. Yeah.
I've had those before. They're delicious.
They are. They're so good, but they were expensive, and I had to reprioritize.
Make sure you're not going to get goiters, though.
Earlier this year, I was also on the gas station diet, which was, energy drinks, pretzels, and protein bars. Highly recommend that one.
Solid.
Nice. Now, you won the state spelling bee in the 5th grade, is that right?
I did. I can't believe you know all these facts about me.
Well, I do a lot of research.
Yeah.
I've got connections. What state was that in?
That was New York State.
Okay. Not the worst of states.
Yeah, so that's like a legit state. When that showed up, I was like, well, is she from like Rhode Island or something? But no, New York. That's big time.
Greg, you are just, our Rhode Island audience just disappeared with that absolute slap in the face.
Did they ever appear in the first place?
Most of our listeners are from Rhode Island. It's a huge but small following.
I kind of think that Rhode Island, much like Finland, doesn't actually exist and is a vast conspiracy.
Dude, you know I love Finland. Why would you say that? That's like my favorite place.
Are you aware of the Finland doesn't exist conspiracy? Because it's a good one.
What?
Yeah,
what are you talking about?
Just Google like Reddit Finland doesn't exist. It's like a whole thing.
But I've been there.
You think you have? You've been to southern Norway.
Somewhere that they called Finland.
Weird. Okay. Well, I have a lot of work to do tonight. I need to get to the bottom of that. So Lauren, this is a question we ask a lot of people that either do a lot of training themselves or coach athletes. Is there anything in your training or anything you have your clients do that maybe goes against the grain in terms of like what a lot of evidence-based people do? Or like maybe anything that there's just no evidence to support it, but you just like swear by it?
Well, I think people turn their noses up at machines, and machines should be given a little bit more credit, especially if you're training for muscle growth. What I see is a lot of people kind of treating strength goals and muscle growth goals too similarly. And you see that with people who prescribe the power lifts to everybody, regardless of whether they are a power lifter. And also just saying, oh, you have to do barbell training or you have to do free weight training. So I think, again, based on goals. But I also personally like doing more exercise variety than is probably backed by evidence.
So like even like week to week, you're kind of constantly cycling through different variations?
Yeah. So what I wonder is, assuming you're going to get the most out of, let's say, your first set, maybe 2 sets, and then it's kind of diminishing value from there. If you're doing 4 sets or 5 sets, then why not do 4 different exercises for that muscle group for just 1 to 2 sets?
I think that's a perfectly reasonable question to ask. And I mean, if nothing else, it keeps training more exciting. Like you can kind of get excited about doing an exercise, but like you're not still excited about doing that exercise on your 7th set, you know?
That's right. And I mean, I think given a complicated exercise that requires more skill, then probably that doesn't make sense. But if you're doing different variations of curls or different kinds of tricep exercises, or I think that should be, in my mind at least, that actually could potentially be better than just doing 5 sets of the same kind of curl.
I really like that. I've been so bored with my training lately. I'll just do a bunch of sets of one exercise and move on. And I get lost in my thoughts, which is a horrible place to be for me. So maybe I should start switching up like that. I like that idea. Now you mentioned the machines. What's your go-to machine that you like?
So I used to be somebody who was super into following a structured program and logging my progress and everything. And then I got busier and I started doing research. And so my personal training is certainly suboptimal, but I'd say when you get burnt out, to just go into the gym and do whatever you feel like doing is the best way to get back into training, as opposed to trying to be optimal all the time.
But like, is there one machine that you just get absolutely stoked to get to?
I'm a big fan of The lateral.
Because there is a right answer for this, but I want to see what you say before I tell you.
There's a right answer.
Correct.
I don't know what you're going to say.
Well, there's actually two right answers. There's the hammer strength horizontal leg press, which is tremendous. They're not a sponsor of the show, but they should be. There's also the hammer strength pullover machine. Super vintage. You can't find them anymore. It's like they're nowhere anymore, but they were so legit. But man, hammer strength, they just don't make them like they used to, Greg. I feel like the more commercial gyms I go to, the newer ones, they just don't load up on the hammer strength stuff anymore, and it's a shame because that stuff was, I mean, if you bought a hammer strength machine 80 years ago, it still works the way it did when you bought it. Those things are so solid and incredible.
So those are fine machines, but I would go with the tibialis anterior machine.
Ooh, that's a good one, yeah.
And also, it's the forearm. Like you roll it up basically to work your forearms, and then you roll it down. You roll the weight up, and then you roll it back down.
What's your highest max on the tibialis anterior machine?
Oh. I have all my clients do 1 RM tibialis anterior.
Perfect. Yeah. All right. Well, Lauren, thanks so much for your time. I appreciate you coming on. If people want to, I mean, like I said, you kind of just started getting into the research world, so people are going to be seeing a lot more of your work moving forward. And if somebody wants to keep up with you and your work that will be forthcoming, how do they stay in touch and stay up to date with that?
Well, you can follow me on Instagram at LaurenCS1, but I only post 6 or so times a year. And generally I just use Instagram to look at videos of Frenchies.
Are you pandering right now? Are you pandering?
No. So did I get you hooked on Frenchie Instagram? The best corner of Instagram?
It was just a mutual thing for the past, I don't know, year.
Yeah. So Lauren understands that when she finds a video of a hilarious Frenchie, she's supposed to send it to me. So, it's probably a little bit of pandering, but okay. So you're using Instagram mostly as a Frenchie vessel for now.
That's right. But I'll occasionally share some other stuff, like pictures of my own dog, videos of my own dog, and then, some science here and there.
Awesome. So any other social media or just Instagram?
That is it. I have a Facebook that I never use. Can you tell how much I love social media?
Yeah, it seems like you've got a good strategy put together.
Well, I will say this. I feel like I don't want to be regurgitating other people's information. And so until I have a unique perspective to share on a topic, I don't see much value in me posting about it.
Yeah. I mean, you do kind of see people who like very clearly take on this idea, like, I'm going to post something every day from here on out. And it's like, do you have a good thing to say each day? Because if not, that's probably not an awesome strategy. Because now you've just become noise on people's timelines, That's right. And it's usually like a selfie in a sports bra talking about protein intake.
Or just like all of those memes where it's like, hey, did you know that the like organic version of Reese's cups have the same calories as the not organic version?
Yeah. Like that's really contributing to society. Thanks.
All of those drive me crazy because it's like, dude, are you just assuming people are too dumb to read a nutrition label?
Greg, what did you send me, or you showed me the other day? It was, wasn't it like a really helpful image telling people not to eat nacho cheese Doritos?
Oh, yeah. It was like instead of snacking on this, snack on this. And it was like fucking nacho cheese Doritos and like steamed broccoli or something. It was like, come on, man. Like no one is going to think like, man, this is my fucking conundrum for today. Like, I'm trying to stick to a diet and I want to snack on something. Do I go with the fucking nacho cheese Doritos or do I go with the broccoli? Man, I wish someone on Instagram would help give me clarity on this one.
The other one I like that you see all the time is like, let's see, you need 30 grams of protein. Should you eat a delicious steak or 113 pounds of broccoli? And it's like, it's all the same. Look how much more full and happy you'll be if you instead eat 7 bowls of broccoli. But the other thing that was a huge flaw with the one that you found with the Doritos is that the Cool Ranch version is way better than nacho cheese anyway. Which, like, if you're going to put out that information, at least be helpful.
I agree. Plus, your mouth doesn't get all orange and your hands don't get all orange.
Yeah. Lauren, did you ever have the special edition Taco Bell flavored Doritos?
I did not, because I haven't consumed Doritos as an adult, but I saw them.
Wait, they still make them?
I mean, I saw them when they came out.
Yeah, because I'm thinking back to childhood. It's kind of like all I had going for me when I was a little kid. Greg, did you ever get the opportunity?
I never had any of the Taco Bell like cross promotion ones, but I did have mini sweet and spicy chili Doritos, which
I remember
that is my dark horse. That is the best Dorito flavor.
Man, I've never had that. What a shame.
It's never too late to try.
And you put them on your fingers and it's like pointy. It's like a cone.
Wait, what are they called? Like bugles or something?
Yeah.
Yeah, those were cool.
That was my dad's go-to. Do you guys remember how gnarly the 90s were when they had the Doritos 3D?
Oh, yeah. Those were so good.
That and like the clear, like all of the Coke Blue,
yep.
and then like the green Shrek ketchup. Like, God, the 90s to early 2000s were just on another level culinarily. Like, I don't think we'll ever get back to that level as a culture.
No, because it was basically like, let's make food really fun for kids by making it as processed as humanly possible.
Hell yeah. We had lower obesity rates back then than we did now. I'm just saying.
Bring back the Dunkaroos. Like,
if you look at the correlation between how much Shrek ketchup is being sold and childhood obesity rates, like, I'm just saying, my evidence-based conclusion is that we need to reintroduce Shrek ketchup back onto the market, and that'll get childhood obesity back down to the levels they were at 15 years ago.
Have you identified the chemical in Shrek ketchup that's curing obesity?
Yeah, it's whatever green dye they use.
It's got to be like a lead-based green dye.
That's the part that's so astounding to me, because, like, tomatoes are really fucking red, man. Like, you need some sort of, like, very hardcore color to not just change the color, because, like, you could put, like, something dark in it and make it darker, but to take tomatoes, which are incredibly red, and make them a very vibrant green color, like, just the sheer level of chemistry necessary to pull that off, I personally, and I don't think I'm alone here, I think that's deserving of a Nobel Prize.
I think that's probably as good a spot as any to end an interview. It's only downhill from here. So, Lauren,
I would like to say that I love Rhode Island, and I wasn't part of any of that really negative, offensive commentary.
I throw out something really offensive at least once per episode, and it comes from a place of love. And also, just let me say, full disclosure, I grew up in the forest, and you're actually only the like 8th woman I've ever talked to who I'm not blood related to. So if I said anything grossly misogynistic, I apologize.
Yeah, I mean, I just want to, as the person that has to edit all the podcasts, like Greg usually says at least one thing per episode that I'm just horrified by. Mm-hmm. Sometimes they sneak through, and usually it'll aggravate, like, 50% of the world population, or like, 18% of the world population. So if we get through an episode and all we did was lose Rhode Island, we're technically like pretty okay. So no one's going to blame you for that. And we're going to survive that pretty well.
Well, I'm a Canadian now, so
So we just gained an entire country of extremely enthusiastic fans. We've tapped into the Canada base, which is big for us.
That's right. I should probably join your podcast as a co-host so you can now tap into the international market.
So actually, Greg is not a permanent co-host. He's on kind of a temporary situation. So we'll talk later.
Okay.
Sure.
Anyway, we're glad that you called in all the way from Canada. Thanks so much for spending some time with us today. And everyone that's listening, make sure you stay up to date with everything Lauren's doing on Instagram. It should be, she's due for another dog post in about 2 months, and then some information about 4 months after that. So make sure you keep an eye on that. All right, Lauren, thank you so much for coming on. Have a great day.
Thank you.
Thanks for listening to the Stronger by Science podcast. Now, Greg and I are not experts in medicine or health or really anything else for that matter. So before you make any changes to your diet and exercise habits, make sure you check with a doctor or another healthcare professional. If you enjoyed this podcast and you'd like to support it, visit strongerbyscience.com to check out the products and services that we offer. Thanks for listening, and we'll see you next time.